Hey everyone, and welcome to the course. My name is Daniel Buckley and I'll be instructor. In this course, we are going to have an introductory look at the game engine known as Godot. Now, Godot is a wildly popular game engine that has definitely increased in popularity over the last few years, as well as including many more features as they have very regular updates. Now, the engine is also free and open source, so you don't have to pay a single dollar throughout your entire development process. Now, throughout this course, we are going to cover a wide range of topics relating to the Godot engine. First of all, we are going to look at creating a new project, installing the editor, and actually then having an overview of how the Godot application works. It's a pretty confusing application on first glance, but we'll be going over all the different windows, buttons, panels, so you can get a well-rounded understanding on how to use the engine. We'll then go over the fundamentals of Godot, as well as an introductory look at 2D game development, exploring concepts such as nodes, scenes, tools, parenting, and cameras. Then we'll move over to learning about 3D, looking at how we can create 3D environments, looking at 3D models, materials, and lighting. Then we're going to move on to the second half of the course, which is going to cover scripting, which is essentially writing down code to provide gameplay behaviors. Zenva is an online learning academy with over 1 million students. We feature a wide range of courses for people who are just starting out or for those who just want to learn something new. The courses are also very versatile. You can choose to follow along with videos, read the included lesson summaries, or follow along with the instructor with included course files. Now let's get started with the first lesson. Hey everyone, in this lesson we are going to be looking at installing Godot. So to install Godot, we first of all want to go to their website at godotengine.org. Now, when you go to godotengine.org, we simply want to go to the download latest button right here, okay? It should be at the top of the screen, a big white download latest with a version number. So I'm going to click on that, and that is going to then navigate us over to the downloads page. Now, depending on your operating system, it should automatically switch you over to the page that is, well, your operating system. So since I'm on Windows, I am on the Windows download page. If you're on Mac OS, it'll navigate you to the Mac page. So what we're then going to do is simply go down to where we have the blue Godot engine button and click that. Now this is then going to begin the download process, and one thing you'll notice is that the engine downloads very fast because it is only around 60 megabytes in size. Now that is great. Godot itself is a very lightweight engine. Again, 60 megabytes, it's not even going to put a dent in your storage space. It's very lightweight, very quick to download, very quick to even open up and use. And when you compare that to a lot of other game engines, which can be gigabytes in size, perhaps even tens of gigabytes in size, it really shows how impressive it is that Godot can stuff all of this functionality into such a small download. So now we are going to open up what we downloaded, which is a zip file. And inside of the zip file, we'll have two files here. We'll have our main engine itself, the executable, as well as a console executable. Now, we don't have to worry about the console. We're only focused on the actual engine itself, which is around, as you can see here, 150 megabytes in size. So what I'm going to do is I'm simply just going to drag this out to my desktop, to a folder. We simply want to extract this file to our computer. And there we go. We now have the Godot engine. And that's another thing. The Godot engine is not something we install to our program files or something that has a whole network of different folders that are built into our operating system. No. Godot, the entire engine, is just one simple executable file, which is pretty amazing. Now, to open Godot, we simply double-click on the executable, and that is going to open up the Godot Project Manager. Now, the Godot Project Manager is not the engine itself, but rather the launcher. This little piece of software is where we will create new projects, as well as see a list of all of our existing ones, because if you're working on multiple projects at once, you probably want to jump between them at some point. So the Project Manager is what allows us to look at all of our projects and click on the one we want to open up and begin editing. Now, in the next lesson, we will be exploring the project manager a bit more, as well as looking at how we can create a new project. So thank you for watching, and I'll see you all then. Hey everyone, in this lesson, we are going to be looking at how we can create a new project in Godot. So what you should have on your screen right now is the Godot Project Manager. Now, if you do not, then simply go over to where you extracted your Godot engine executable and double click on that. Okay, that should then open up the Godot Project Manager. And this is a piece of software which basically acts as the launcher for Godot. This is not where we are going to be creating or editing our game projects. This is essentially where we will manage all of our projects, okay? Because eventually you'll be having tens and maybe even dozens of different projects that you have created in Godot. And this is going to basically display them as a list so we can click on them to open them up. But at the moment, as you can see, we have no projects, so we have to create one. Now, to create a new project in Godot, we simply want to go to the top left corner of the screen and select the Create button right here. That is then going to open up this little window here. Now, in this window, we can edit a few things. First of all, we have the project name, which is going to basically be the name of our project. So I'm going to call this one Godot Introduction, okay? And then down below we have the project path. Now this is where we are going to be storing our game's project folder. Now the project folder is not the actual game we'll be running when we want to play it or send it over to other people to test. Rather, this is going to be the folder that contains all of our scripts, our scenes, our textures, our sprites, our 3D models. This is going to be holding all of the data and assets for our game before we build it into the final product. So we want to put this in a location where we know it's going to be safe. So I would recommend storing this in a dedicated folder that you have for all of your Godot projects. So I'm going to click over on the Browse folder right here and navigate over to a folder where I store my Godot projects. So once I have found that folder, I'm simply going to click Select Current Folder at the bottom. And here we are. Now you'll see that it will also automatically add in a new folder name here based on your project name, okay? And do make sure that you do have the green text down here saying that everything is okay. And there is more information down here about rendering, which we don't really have to go into. Just make sure that / is enabled by default, as this is the standard renderer for Godot. Then finally, we can go down to the bottom and click on Create. The project manager will then close, and what will open is the Godot editor. This is now the application where we will create our games, write our code, and test it out. Now, at a first glance, there is a lot going on. We have this weird grid in the middle of our screen. We have all these different boxes with buttons and text and all little icons that we can click on. There's a lot to wrap your head around. And again, it's going to look confusing at first, but throughout this course, we are going to go step by step through all the important tools and aspects that you will need to understand. So don't worry about not understanding anything at the moment. That is totally understandable. In fact, in the next lesson, we are going to have an overview of the Godot editor here and hopefully give you an understanding of what everything here generally does. So thanks for watching, and I'll see you all then. Hey everyone, in this lesson, we are going to be exploring the Godot editor. So once we create a brand new Godot project, the Godot engine is going to open up, and this is where we are going to spend all of our time designing our levels, importing our assets, writing our code, and testing out our game. Now, what you see before you is known as the editor, and the Godot editor is divided up into a number of different docs. Now, these docs are these little self-contained rectangles which each have their own functionality, and we are going to be going over what each of these do. Okay, but in essence, a doc is essentially there to serve a specific purpose in helping you develop your games. Now, as well as having these docks, we can also click and drag on the edges of them to basically resize them. So for example, if you want this dock here to be a bit wider, we can do that. Same thing for over here on the right-hand side, we can click and drag. So feel free to experiment with changing the size and dimensions of your docks. Now, let's get started with the first dock we are going to explore, and that is going to be down here at the bottom left, and this dock is known as the file system. Now, the file system is essentially like a file explorer, but for our game project. So on your computer, you likely have a file explorer where you can navigate through your folders to find certain files that you might want to open or modify. Well, we have the exact same thing here. And the file system, as you can see, down here has a list of all these folders and these assets. So we can open and close the folders by clicking on the little arrows, and then we can see the contents within them. Now, by default, it's pretty empty. We only have one folder and one little icon image, which is just the default icon for our game. But as we continue, we will be creating new assets such as scenes and scripts. And if you wanted to import stuff such as textures, sound effects, or 3D models, this is where you would see them displayed and where you would then be able to implement them into your game. Now, the next dock is going to be this central one right in the middle. Okay, this is the biggest dock in the engine, and this is where you're going to be spending a lot of time. This is essentially a viewport into our game world, and this is where we are going to develop our levels, where we are going to connect all the bits and pieces for our game. Resizing our colliders so they match the dimensions of the player. Adding materials and checking to see that the colors work just right, and making our game look the way that we want it to look. Now, since Godot is a versatile engine, it allows us to edit in both 2D and 3D spaces. Now, by default, as you can see, we are in a 3D viewport right here. You can see we have these different colored lines, and they all vanish into the distance. So this is the setup that we would use for a 3D game. But how do we switch over to a 2D mode? Okay, if we want to start adding in sprites and text and different UI elements, how do we switch over to a 2D perspective? Well, at the top of our screen here, you'll see that we have a number of different buttons, and these basically change what gets displayed in this central dock. Now, by default, as you can see, we are in 3D mode, but if I go over to 2D, that is going to change the central dock to basically display a 2D environment, and this is then where we would develop our 2D games. Likewise, we also have a script button here, and this is going to take us over to Godot's built-in scripting editor, which is fairly great, as most game engines require you to install a third-party software and use that, but with Godot, we have the scripting built into the very engine itself. But at the moment, of course, we have no scripts to actually display or edit, so this window is going to be a bit empty. Now, let's just hop back into our 2D viewport over here, as this is what we are going to be using for much of this course. Now, the next dock that we're going to go over is this one at the top left, the scene dock. Now, the scene dock is essentially going to display all of the nodes that we have in our current scene. Now, what are nodes and what are scenes? Well, we're going to be going over these in a bit more detail later on, but essentially, a node is the building block for any element in our game. For example, the camera would be our node, our player would be a node, the little rocks and particle effects, those would all be nodes in our scenes. This is how we build out our levels. And a scene is essentially just a collection of nodes. You can think of it like a level. So in this scene window right here, in this scene dock, this is where we are going to display a list of all the nodes that have been created in our scene. And in the central viewport here is where those nodes would then be rendered and positioned. So what we need to do is, you can see here it says create root node, and that is because in each scene we must have a node which basically acts as the container for all other nodes. We're going to go over the idea of parenting and children with nodes, but essentially nodes can have children which will follow them around and copy some of their attributes, and we are going to have one main root node which has all of the rest of the scene as a child. So Again, it might be a bit of a complex concept to think about with children, parents, scenes, nodes, but essentially we are going to go up and select 2D scene, and this is going to create a node in the panel here, okay? Now you can see on the left hand side we have a little icon, so this little blue circle indicates that this is a 2D node, and if we hover over it you can even see it is of type node 2D. We also have a name for the node here. If you do want to rename it, we can just double click on that and we can then edit that. So I might call this my main node, just like so. And one thing you'll notice is that when we select the node here in the scene doc, something happens over in the inspector, okay? In the right hand side, the inspector doc is the last one that we are going to go over. And this doc is very important as the inspector essentially allows us to have a peek inside of whatever node we have currently selected. Now, with your nodes, these are going to have dozens and dozens, maybe even hundreds of different attributes and properties. Okay, for example, a position, a rotation, a scale. If we are working with a sprite node, that node is going to have a texture property that we can assign. If we are working with a collider node, that node is going to have the ability for us to define the dimensions and the shape of the collider. Okay, so each node is going to have different properties that we can modify. And you can see in the inspector here, we have all these different categories. So for example, if we go to transform and open that up, you can see we have all of these transform properties, such as position, rotation, scale, and skew. And these are fields that we can go in and modify. Okay, so this is how we can then customize our nodes to give them the position, the rotation, the size, the color, or any other thing that we might want to modify on them. We'll of course get into much detail later on the inspector and all the different properties. There are quite a lot here, as you can see, but do keep in mind that these are properties that you're not always going to be modifying. Okay, for example, down here in auto translate, you'll likely never really touch much of this stuff, and if you do, it's only going to be specific things, okay? You're never really going to be modifying every single property here, as that of course would take a long time and it would be a lot of work. So mainly you're going to be modifying a couple properties on a node, a couple here, a couple there, to basically build out your games. Now, how do we actually play our game? Well, if we go up to the top right corner of our screen, you'll see that we have these buttons up here. Now I'm going to click on this first one, which says Run Project, and this is going to ask us to basically select a main scene. This is going to be the scene that gets launched when we play our game. I'm going to click Select Current, and since we haven't actually saved our scene, it's going to ask us to save it here. So I'm just going to save it as main to our file system and click Save. Now, next thing that's going to happen is our game window is going to appear right here, basically rendering what we see on our screen. But since we have nothing to show, well, our screen's going to be blank. Now we can go over to the top right corner and click on the stop button right here to basically stop playing our game. And also note that when we saved our scene, it now gets added to the file system down here. And we also had this other window down at the bottom appear, and this is known as the output. Now we can click on this little button here to open and close it. The output is basically a console log, okay? If we have any messages that we want to display to the developer, they can be printed here. If there are any errors with our scenes, our nodes, or even when it comes to scripting, those errors will be logged here as well, so we know how to come about and fix them. Hey everyone, in this lesson we are going to be looking at how we can navigate around our scene inside of the Godot engine. So here in the center of our editor we have our main viewport, which is basically a viewport into our game world. This is where we would be placing down our nodes, our different assets, and basically building out our levels. Now, when doing this, we probably want to be able to zoom in, zoom out, and move around our scene. Okay, so how can we do that? Well, here inside of 2D mode, we are going to go over the 2D navigation controls first. So make sure at the top of your screen that you are over in the 2D viewport here. So first and foremost, how do we zoom in and out? Well, we simply scroll up and down with our mouse wheel to zoom in and out like so. We can then pan by holding down the middle mouse and dragging our mouse around. So that is going to pan our screen like so. We can then combo that with a zoom to basically navigate around our scene here, okay? And those are the two main ways of navigating around a 2D scene. But what if we are creating a 3D game? Well, if we go up to the top and go over to our 3D viewport, there are a few more controls. First of all, we can zoom in and out with the scroll wheel again, just like before. We can also then hold down the middle mouse and drag, and this is essentially going to orbit. Now, you can think of our camera looking at a certain point in 3D space, and holding down middle mouse is essentially going to orbit our camera around that point. We can then hold down the right mouse button, and this is going to turn our camera into a sort of first person view, okay? So it's going to act as if we are controlling the direction of the camera. Now, when you are in this state of holding down the right mouse button and looking around, we can then use the W, A, S, and D keys to essentially fly. So it's going to be kind of like you're playing a video game, okay? You're looking around and you can use the W, A, S, D keys to fly around. You can then also use E to go up and Q to go down, okay? So we can then navigate around our 3D scene this way. And if you are using the WASD keys, you can hold down Shift, and that is essentially going to move you at a faster rate, okay? Sort of like you are running around. So hopefully these controls are fairly intuitive. We will of course be using them a great deal when working with our games. For example, in 2D, when we are developing our levels, we probably want to be able to zoom in to adjust some fine details, zoom out to see the greater picture, and then pan around to go to different parts. Likewise, for 3D, we of course want to be flying around to different parts of our level. We might want to put something over here, might want to go over here to then look at something else there. So understanding these different navigation tools is going to be very important. So, thanks for watching, and I'll see you in the next lesson when we go over importing assets. Hey everyone, in this lesson, we are going to be going over how to import assets into your Godot project. Now, first of all, what is an asset? Well, an asset is any sort of file that you might want to use in your game project. So these would be things such as textures, as sprites, as sound effects, music, 3D models, materials, any sort of file that you want to utilize for your game is known as an asset. And down here in the file system, this is essentially a file explorer that is going to be listing out all the folders and assets that we have in our project to use. Now, if you go over to the course files tab of this course, you should see a downloadable zip containing the assets that we'll be using for this course. Simply download that zip file, extract the contents to your computer, and inside you should see that we have a sprites folder here. Now, inside of that sprites folder, we have two images. We have a coin and a player image. Now, we are going to be utilizing these in our game as little sprites that can move around and be collected. So what we're going to do is down in my file system, I'm going to start by creating a folder to essentially store those sprites. So to create a new folder, we simply just want to right click, then go over to where it says new folder, and we can give our folder a name. So I'm going to call this one sprites, click OK. And as you can see, that is then going to create a brand new folder right here. Now what I'm going to do is I'm going to select the folder that I want to basically import our assets to. I'm then going to open up the file explorer which contains my sprites. I'm then going to select them both and then drag them into the file system. And you should see that the mouse cursor is going to change to this sort of import icon. I'm going to let go. And if I go back to the editor, you can see there's going to be a little progress bar. And once that is done, the sprites folder, you'll see there is a little arrow next to it. Now, if I click on that little arrow, that's going to open up the folder and show us the coin and player PNG right here. Now, if you want a bit more information about what this asset is, we can double click on it, and that is going to basically open it up here in the inspector. So we can see the image here, we can then see its resolution and some other settings as well. Okay, so that is how we can import assets into our game project. The same thing works if you're using audio clips, if you're using 3D models. Those can be simply imported by dragging them into the file system, and that is then going to import them into the project. Hey everyone, in this lesson we are going to be looking at nodes and scenes within the Godot engine. So first of all, what is a node and what is a scene? Well, essentially, nodes are the building blocks of our game. They are basically what everything is made up of. As in our world, everything is made up of atoms. In Godot, everything is made up of nodes. Now, a node can be pretty much anything. A node can be the player. A node can be the player's sword that is strapped to their back. A node can be a rock in the environment. It can be an enemy. It can be the terrain. Basically anything that you want to give a distinct aspect to, that there can be a node. So nodes are essentially going to be the building blocks of your game, and you are going to have anywhere from a couple dozen to thousands within your game, depending on its complexity. Now, scenes, on the other hand, those are essentially collections of nodes, okay? You can think of a scene in many ways as like a level, okay? A level might have a player, it might have an environment, it might have some enemies, it might have an end gate to go to the next level. So all of those nodes would be collected into one scene, and we might call that scene level 1. So then we can load that scene into our game and play level 1. We might also have a menu scene, we might have a level 2 scene, etc. Okay? And scenes themselves can also act as nodes, okay? That is what's great about Godot, is it is a very modular engine, meaning that we could create, for example, a scene that contains just the nodes for the player. Okay, and we could call that the player scene. And then, whenever we want to use our player in our game, we don't have to recreate our player from scratch using all these nodes. All we need to do is just use the player scene, which can then be spawned in as a node. Okay, again, these things are a bit complex, but we will be getting into exactly how they work. Now, over here in the top left dock, we have our scene, and this here basically is displaying all of the nodes in our current scene. Now, previously, we went ahead and saved this scene to our file system. You can see down here, a scene has the file extension of tscn, and that there is basically the scene containing all of these nodes. Now, right now, our scene only has one node here, which is going to act as the root node. Now, in Godot, every scene has a root node. This is essentially the origin, you can think of, and it holds all of the other nodes within that scene. So how do we go about actually creating a new node? Well, what I'm going to do is I'm going to click on this plus icon at the top left corner of our scene dock, and that is going to open up the Create New Node window. Now, you can see here there are a large number of nodes that Godot has by default, and if we open up these little drop downs, you can see there are even more. Now, basically what's important to note is that all the nodes that are associated with 2D are going to be blue, all nodes that are 3D will be red, and these green nodes here are for UI elements. All the other nodes that might be white or some other color, those are nodes that we can pretty much just use wherever. So I'm going to go to where we have the Node 2D section and open that up. And I'm going to scroll down through all these different nodes. So we have bones, we have cameras, collision shapes, particles, lines, markers, so many different nodes that Godot can provide for us. I'm going to go down to the bottom where we have a Sprite 2D node. Now, Sprite 2D essentially allows us to render a texture to our screen, which is pretty cool. So I'm then going to go down and click Create. And this is going to add that new node here to our scene. You can see it's indented a little bit, meaning that it is a child of the main node. Like I mentioned, every node in our scene is going to be a child of the root. Now, with this Sprite 2D, you can see it has its own little custom icon on the left-hand side to basically allow us to easily see that it is a sprite. And by default, it is called Sprite 2D, but I want to rename this to Player. So I'm going to double-click on Sprite 2D, and I'm going to change this name to be called Player. And there we go. Now, with this node selected, you'll notice that over in the inspector, we suddenly have access to all of its properties, okay, such as texture, offset, animation, its transform properties. We can come here and modify pretty much any aspect of this node that we wish. Now, the main draw of a Sprite 2D is assigning a texture for it to render to the screen. So over here at the top of the inspector, you can see that we have a texture property, and on the right hand side you can see it is empty. So what I'm going to do is I'm going to go over to my file system, I'm going to go down to where we have the player.png, and I'm simply just going to click and drag that into that texture field right here. Now, that's going to assign the texture to the property, and we can see it displayed here. And then inside of our scene view, you can see that we have the sprite now rendering in our world, which is great. Okay, so we have the texture assigned. You can also make sure to zoom in and pan around with the mouse. If the camera is very far away and you're not too sure where it actually is, then you can simply, with the node selected, press the F key, and that is going to focus in on that node, okay? So it's great. We have our node rendering in our scene. Now, if I save this with Control S and then go up to the play button, you'll see that, well, we're rendering our player, but it's kind of in the top left corner. So we want to move it down to the center. So the way that we can move our player around is if we go into the inspector, we can go down to the transform property right here, or the transform section, and you'll see that we have a position property here, which has an X and a Y, okay? The X position is essentially horizontal, and the Y position is vertical. You can see the X here is red, which corresponds with the red horizontal line, and Y, which is up and down, is green, just like the line itself. Now, coordinates and units in Godot in 2D are essentially in terms of pixels. So if I go to the X property here and change that to be 20 and hit enter, you'll see that my character is now going to move 20 pixels to the right. Let's actually set this to be 200. Now they are 200 pixels to the right. Now for the Y, if I set that to something such as negative 150, they are going to move negative 150 along the Y-axis. But if I set that to positive 150, they are going to move 150 pixels down, okay? Now if I save that and press play, you'll see that we are now rendering our character right here. There are also other properties we can modify, such as the rotation. We can click and drag on this little bar to basically change the rotation of our node here, which is pretty cool. Same thing for the scale. We can set our scale to a different number, and that's going to change its size. Now, in the next lesson, we are going to be looking at how we can actually start working with scenes. So thanks for watching, and I'll see you all then. Hey everyone, in this lesson we are going to be looking at how we can utilize scenes inside of Godot. So I'm going to set up a little example here. What I'm going to do is I'm going to go down to my file system, I'm going to select my coin image, and I'm going to drag that into my scene right here. Now this is essentially a shortcut with creating a new Sprite 2D node and assigning the texture to it here. So that's just a quick way of creating a new Sprite 2D with the texture. Now, I'm going to do this a couple times, dragging in my coins here, and let's just say we are creating a game, right? We have these nodes which are acting as our coins, and we have a lot of them around our level. Now, let's just say I have the decision that, I might want to change the color of these coins. Well, we can select a coin node, then in the inspector, go down to Visibility, and here you'll see we have a modulate property. Now if I click on this white box, this is going to open up a little color picker, which I can then begin modifying and changing the color of. So I might want to make this coin green, for example, something like this. Okay, so I'm like, okay, I got my coin green, but I want all the coins to look the exact same. I want all the coins to behave in the same way. So then I'll select the next coin, I'll go Visibility, Modulate. I'll change this to a sort of greenish color as well. Then I'll go to the next one and change that as well. And you can see how this can be a bit of an issue. If we have, for example, 100 coins in our level that we want to change the color of, or we want to change the amount of score they give the player, or we want to change the speed at which they rotate around, that is going to take a very long time, as we have to go one by one through each of those nodes. So what is an easier way of doing this? Well, an easier way, and I'm just going to undo all my changes here with Control Z, is to go ahead and create this node and save it as a scene. Okay, if we set this node to be a scene, that means that all changes that we make to that scene will be applied to all of its instances that we create in our level. So how do we do that? Well, what I'm going to do is delete all of our other coins here, just because we don't need them at the moment. And with my coin right here, I'm going to right click on that node and go down to where it says Save Branch as Scene. Okay, I'm going to click on that. I'm then going to give my scene a name, so I might call this one coin.tscn, of course, and click Save. So that's going to save the coin scene down into my file system here. Now what I can do is I can select my coin in the scene, and you'll see that it is no longer just a normal node. It has this little icon next to it, which essentially says that this node right here is actually a scene. Because remember, scenes and nodes are essentially the same thing, okay? Nodes, again, are the building blocks of our games, and scenes are collections of those nodes. Now, scenes can also act as nodes, so you could have a scene with a scene inside of it, with a scene inside of it, so you can get quite complex, and that allows for a lot of flexibility in how you develop your games. So I'm going to select this coin node that we have here, and I'm going to go Control-D to duplicate it. Then what I'm going to do is I'm just going to click and drag to move it over. I'm going to do the same thing again, so that we have 3, and then we might have 4 coins as well. So again, if I wanted to change the color of this coin, I would have to go one by one for each of these nodes. Or what I can do is I can go down to my file system, double click on the coin scene right here, and that is going to open up a new tab in my central viewport here. You can see at the top we have the main tab and the coin tab. These are essentially the scenes that we can access. So our main scene, we can easily click on it to go back here. If we click on the coin scene, this is going to be a scene that just has the nodes associated with the coin scene, that being the sprite 2D node. Now, if I select this node, go down to visibility, modulate, and I change the color of this, maybe I want to change this to a red color, maybe something like this. I can then save the scene with Control S, go back to my main scene, and what you'll notice is that all of these nodes now have that change applied. The reason why is because these are no longer their own insular nodes. These are instances of the coin scene. So any changes that we make to this coin scene over here, those changes will be applied to every instance of that scene, okay? It doesn't matter if we have just 2 coins in our level or 1 million. If we make a change to the scene, all instances of that scene will have those changes applied. So we can then go back to our coin, we might go transform, we might change the scale to be 3, so it's a big coin, go back to main, and those changes are going to be applied, okay, just like that. So you can see now the power of utilizing scenes and nodes, and I'm sure you're starting to think about what sort of things you would make as a scene. If in your level you have dozens of different enemies that are moving around, I would recommend creating those enemies as scenes, okay, as you'll then just be able to drag them in and have them all behave on their own. And if you want to, for example, change their move speed or change their attack damage, all you have to do is go to their scene and change the property there. Now, since our coin is a scene, that means we can add nodes to it. So if I go over to my coin scene, I could then, for example, maybe add in another sprite 2D node here. Let's then attach the coin as a texture to that. Might move this up. Whoops, so select the coin, move that up here. We could then maybe go visibility, change the color of this to something else. Really, this is up to you. I am just messing around at this point, just to show you how, if we add new nodes to our scenes, those also get applied. Might then change the scale to be something like 0.5 and just move it over here. So now we have another node in our coin scene. If I save that and go back to main, you can see that that extra node is also applied to all of the instances as well. The one downside being is that we cannot actually access any of those additional nodes. We can only access the root node of the scene that is being instanced here, okay? Which isn't that big of a downside, because if we want to modify this little node here, we can simply just go back to the scene and change it there, just like that. So feel free to experiment with setting up nodes and scenes and saving a scene and then duplicating it a bunch of times just to see how that works and so that you get familiar with it. Now, in the next lesson, we are going to be going over node tools. These are going to allow us to rotate, move, and scale our nodes. So thanks for watching, and I'll see you all then. Hey everyone, in this lesson we are going to be looking at node tools. Now these are essentially ways of us to modify our node's position, rotation and scale inside of our game. So as you can see here, we already have a bunch of sprite nodes. Now let's just say we want to move our player here around to a different position. Well, by default, when we click on the player, this orange box will appear around them, okay? And if we look at the top left corner of our viewport, you can see we have a bunch of different buttons that we can select, and these are all either tools or different settings for the central viewport here. Now, what we're going to be looking at in this lesson are these four right here. We have the select mode, we have the move mode, the rotate mode, and the scale mode. So if I click on a node, it will select it, and we can then see in the scene doc here, the node is selected, and in the inspector, we can see the properties here. Now, what we can then do is click and drag to basically move this node around and have a look over in the inspector at our position property. When I do that, you can see I'm actually modifying its X, which is again left and right, and its Y, the up and down position, okay? And we can pinpoint a location in our game world for it. Now let's look at the move mode or the move tool. So we can select it up here by clicking on it, or we can press the keyboard shortcut W, and you'll see that we have a little change happen, okay? We no longer have those little dots around the outside. Instead, we have this red and green arrow, as well as our mouse cursor changing to this cross. So what we can do is, just like before, we can click and drag to move this node around. Or if we click and drag on these little arrows, you can see if I click and drag on the red, it is going to only move it along the X-axis, okay, left and right. Same thing for the green arrow. This is then going to move it up and down along the Y-axis. So that is the move tool. Also, if you want to go back to the select mode, because as you can see, I can't actually select any nodes at the moment, we can press the keyboard shortcut Q. That's going to return us back to the select mode. I can then select other nodes then. Okay, so we have the select mode, which allows us to select nodes, and then the move mode, which with the keyboard shortcut W allows us to move them around, more specifically on their axes. Now, if we go up to the next tool, which is rotate mode, with the keyboard shortcut E, we can then rotate our nodes around. So to do this, we just click and drag like so, okay? And you can see over here in the inspector, we have our rotation property changing like that. Now, this is in terms of degrees. So if I have my character at 0 degrees and then move them 90 degrees, they should then be horizontal like this, okay? Now, if you want more incremental rotation, then when you are rotating your node, simply hold down the control key, and this is going to then snap their rotation, okay, in terms of, I believe, around 15 degrees at a time. Now, as well as modifying the rotation here, we can always just go in and give ourselves a direct degrees here. So we might go, I want to give my character 40 degrees, okay, and then it will adjust it like that. We can also click and drag on this little slider here to adjust it likewise. Okay, now the final tool we are going to explore is going to be scale mode with the keyboard shortcut S. Now scale mode, if we click and drag on our character, this is going to allow us to change the size of our character. Now you can see over in the inspector, this number is not in terms of pixels and it's not in terms of degrees. So what does it mean? Well, if I reset my scale, you can see it is at a scale of 1. Now, you might be going, okay, what if we set that to 0? Well, if we set our scale to 0, then our character or our node basically is infinitely small. Don't think of scale as in terms of pixels, but rather think of it as in terms of percentage, with 1 being 100% of its original size. So that means if I set it to 0.5, that means the node is now 50% its original size, and thus if I go 0, it's 0% its original size. Likewise, if I set it to be 2, that will then be 2 times its original size, okay? Now, you may be clicking and dragging on your node here and going, you know what, I don't want this ununiform scaling. I want my node to scale up uniformly. Well, for that, we can simply then hold down the Shift key while scaling and clicking and dragging to scale up along both axes equally. Likewise, we can click and drag along the red line here to scale along the X-axis, and then click and drag along the green to scale along the Y-axis. So those are the four main tools that we have to basically modify our nodes inside of our scene viewport here. Again, we have the select tool, which allows us to select nodes, and those then get highlighted in the scene dock, and we see their properties in the inspector. We then have the move mode, which allows us to move a node around. We then have the rotate mode, which allows us to change their orientation. And then we have the scale mode, which allows us to change the size of a node. So these are all the tools that you'll be using in both 2D and 3D. Now, if you are wanting to go down the 3D pathway of creating games in Godot, then there are a few little differences with how these tools behave, but generally they have the same principles. So have a go at experimenting with these four different tools. Okay, so now I have a bit of a challenge that I want you to complete. So what I want you to do is, first of all, create a new Sprite 2D node with the player texture, then duplicate, position, rotate, and scale those nodes so that they match the image on the right, okay? I want you to have a go at this before starting the next lesson, as in the next lesson, we are going to go over the solution. So thanks for watching, and I'll see you all then. Okay, so I hope you had a go at that challenge. Let's now hop into Godot and begin looking at how we can set it up. Okay, so here inside of the editor, the first thing we want to do is, as the challenge states, create a new Sprite 2D node with the player texture. Now, we could go up to the top left corner of our scene dock here and click on the Add Child Node button, search for Sprite 2D, create it that way, assign the sprite texture, or we can use the shortcut of just dragging in our player texture here into our scene. And that is going to automatically create a Sprite 2D node, and it is going to then assign the texture. Now what we're going to do is we are going to duplicate this player with Control D, and I'm going to move them over to the right hand side. We can then scale them down, so I'm going to press S to go to the scale tool, and then holding shift, I'm going to click and drag so that they are around this size. We can then go to the move tool by pressing W, position them here, duplicate them again, and then clicking and dragging on the red arrow just to make sure that they are along the exact same axis. I'm going to move it over here. Now what I'm going to do is I'm going to duplicate this again, move this little sprite up here. I'm then going to scale them down slightly more, and then I'm going to press E to go to the rotate tool, and holding down shift, holding down control, I'm going to snap them to about 45 degrees. We can even open up the transform property here and make sure, yep, 45 degrees. Position them like that. Then I'm going to duplicate it. I'm then going to move it over here, but I want it to be still along the exact same x-axis. But if I click and drag on the red arrow, you can see we are dragging along this way. But what we can do is when we are dragging, we can hold down shift, and that will sort of snap it to an axis. Okay, you can see here I am currently snapping along the x-axis. If I pull down, we'll start snapping along the y-axis. So holding shift will essentially snap it to one specific axis. So I'll move it over here, then go to the rotate tool, holding down control, we'll flip it over that way. We can then select both of these nodes. So I'm going to click on the first one with the select tool, holding down shift, I'm going to click on the second one, then I'm going to go Control D, I'm then going to go to the move tool, I'm then going to drag them down, and you can see you can select multiple nodes at a time and move them around. Likewise, you can also rotate multiple nodes at a time as well, but as you can see, it's not really going to work in this way as we want, so I'm then going to select just this one on the right and rotate them around like that. And there we go, we now have the challenge completed. So from here, I recommend experimenting much more with the select, move, rotate, and scale tools, as they are going to be your bread and butter when designing your levels and setting up all the different little bits and pieces for your games. Hey everyone, in this lesson we are going to be looking at the idea of parenting with nodes. Now for this lesson I'm going to go ahead and create a brand new scene, just so that we have a nice clean slate. So to do this, I'm going to go up to the scene button at the top left corner of our screen and go down to new scene, or Control N. This is going to create ourselves a new scene. As you can see, a new tab has been added at the top, and we must then choose a root node. Now, we're still going to be working in 2D, so I'm going to select 2D scene, And then we can rename this node here, our root node. Now, I typically like to call my root nodes main, or you can call it whatever you wish. I'm then going to save with Control S, and I'm going to save this as parenting, okay, .tscn, and then save that. That scene then gets saved to our file system, and we can begin working with it. So, what we're going to do here is go over the concept of parenting and children with nodes, okay? So for this example, I'm going to drag in my player PNG to create a new Sprite 2D node, as you can see here. Now, when we are creating our nodes, they aren't all going to act as their own individual little things, okay? For example, with our player, we might have a sprite for our player. We might then have a collider node for our player. We might then have a node that represents a particle effect for their footprints. We might have some other sound effects that we want to track along with our player, okay? All these different nodes that we want to associate with our player. Now, when our player moves around, we also want their collider to follow them along. We want their sprite to follow them along. We want the particle effect to follow along. We don't want them to just sit there in the world while everything else is moving about. So we can do this with the idea of parenting. Now, what I'm going to do for an example is show you how we could parent a collider, for example, to a node. So what I'm going to do is I'm going to select our player node here. I'm then going to right click on it and then go down to add child node. This is basically the same thing as going and clicking on the plus. So I'll go add child node, and then here I'm going to search for collision shape 2D. We can see that collision shape 2D node right here, and I'm going to click create. Now, what you'll notice is that this node is added to the list and it is indented. You can see it is indented inside of the player node here. That means the collision shape 2D node is a child of the player node. Okay, we have that child-parent relationship here. So, on our collision shape 2D, let's then go over to the inspector, go over to the shape property, and if we open up this with a little drop down, we can choose a shape that we want our collider to be. I'm going to select new rectangle shape 2D, and you can see over in the viewport here, we now have this blue box that appears. Now, we can click and drag on these little circles to basically change the size of our collider, and if we hold down Alt, we can sort of resize it from the center. So if I set this to be the bounds of our player like so, we can also adjust it by clicking and dragging on the other ones. We have essentially created a little collider for our player, okay? So this is going to allow us to then bump into obstacles. Now, if I then select my player node and I press W to go to the move tool, look what happens if I move it around. That collider shape is also following along, okay? And that is because the collider is a child of the player node. And what that means is that every single child node, it will follow along when the parent moves. It'll also rotate with the parent and scale with the parent. So if I go ahead and then rotate the player node, you can see that collision shape is also rotating. If I then scale it, so too will it scale. Now, as a bit of another example, let's go ahead and maybe give the player an item to hold in their hand. So I might drag in the coin, place it over their hand, and then to make this coin a child of player, I simply have to click and drag it over the node I want to make it a child of. So I'm going to click and drag it over the parent, and there we go. You can see the coin is now added to the list of children nodes for the player. Now, if I don't want this coin to be a child of player anymore, I can simply drag it over the root node, and that will then make it a child of the root node, which everything must be inside of a scene. But I want it to be a child of player, so I'm going to drag it over player again. There we go, it's now indented. And then if I move play around, you'll see that that coin and collision shape are also moving. So this is the power behind the children and parenting of nodes, okay? Everything in your scene is going to be a tree, a web of parent nodes, children nodes, children of children nodes, for example. So if I drag coin over the collision shape, now coin is a child of the collision shape. So if I then move collision shape around, you can see that the coin follows along. But I want to just be a child of the parent there. Now, this is a very important concept when it comes to Godot. As like I said, Godot, everything is made up of nodes and scenes, and to get more complex behaviors out of your game, you're going to have nodes that are children of other nodes. Now, If that concept isn't fully understandable by you right now, then that is fine, okay? I am just introducing it to you in this lesson, so I don't really expect you to have a complete understanding of it just yet. But throughout this course, we will continue to look at ways of implementing these parent and child relationships with our nodes. So from here, I recommend you go ahead and start experimenting, okay? Create a bunch of different nodes, make them children from other nodes, and just see how they react. Because as you can see with our player, if I rotate them around, you can see that this little coin is rotating along as if it is basically a part of this node itself, which as a child, it essentially is. So thanks for watching, and I'll see you all then in the next lesson. Hey everyone, in this lesson we are going to explore another aspect of the Godot engine, which is 3D. Right now in this course we have been working in 2D, so basically 2 dimensions, but in this lesson we are going to explore 3D, which adds that 3rd dimension. Now to do this, we are going to go ahead and create a brand new scene, which is going to be for 3D. So to do this, I'm going to go up to Scene, then New Scene, and here inside of our new scene, I'm going to select 3D scene. Now, what's going to happen is our root node is going to be created, and then since that is a root node of 3D, you can tell by the red icon, we are going to switch over to the 3D mode up here. Okay, so our viewport is now in 3 dimensions. And if you remember from an earlier lesson, we can hold down the right mouse button to look around the camera, and while doing that, use the WASD keys to fly around. We can also use E to go up and Q to go down. So that is how we can navigate around our 3D environment. Now, I'm going to go ahead and save this scene with Control S, and I'm going to simply save this as our 3D test. Okay. Now, what we can do is go ahead and begin experimenting with 3D inside of Godot. Now, with 2D, we were using sprites to represent our items and objects in our world, but in 3D, we use, well, 3D models, okay? 3-dimensional objects that have shape and volume. Now, how do we create those? Well, what we're going to do is we're going to go over to our scene dock and click on the little plus icon right here. And what we're then going to do is search for a MeshInstance3D, okay, MeshInstance3D. We're going to create that. And the MeshInstance3D is basically a node which can render a 3D object to our screen. Now, if we go over to the inspector, you'll see we have a mesh property right at the top. And if I click on the little down arrow here, you can see we can choose between a number of different simple meshes. Now, if you have your own custom mesh that you've imported into Godot, you can add that here. But for us, we are going to go over to New Box Mesh, which is essentially a cube. So you can see now we have our cube being created right here. And we can then, of course, modify it using the node tools. So, like in 2D, we have our node tools to move, rotate, and scale. The same thing here in Godot. Right now, we have the select mode selected, so we can click on our cube to select it. We can then move over to the move mode, and this then has our 3 different arrows that we can use. Because remember, in 2D, we are only utilizing an X and a Y axis, okay? 2 dimensions, 2D. In 3D, we have 3 dimensions. We have X, Y, and then this blue one, which is Z. And likewise, we can click and drag on these arrows to move it around. Same thing for the green one for up and down, and blue for forwards and back along the Z axis. Now, if we go over to our transform properties here, we can see we have a position property, which has an X, a Y, and a Z. And if I begin moving the cube around, you can see that it is being modified. But it is not in terms of pixels. In 2D, we move around and position our objects in terms of pixels, whereas in 3D, we use meters, okay? Because since in a 3-dimensional world, it's a lot easier to gauge distances and measure size using units that we use in our real world, such as meters. So you can see here, we can move our cube around, and it is then going to be appropriately positioned and basically updated here in the property. Now you'll notice on our cube that we also have these three little squares, and these, if we click and drag on them, allow us to move along two specific axes only. So if I click and drag on this green, that basically means we will be moving along the X and the Z axis and not the Y. If I click and drag on the blue, we'll be moving along the Y and the X, and if I click and drag on the red, we'll be moving along the Y and the Z. Okay, so if you want to, for example, place something on the ground and then move it along the ground, you can simply do it like this, and it just makes it a lot easier. But of course, we can always go into our inspector and manually enter in numbers for these properties. So I might go 0 on the X, 0 on the Y, and maybe 2 on the Z. And then we can finally and precisely move our nodes around that way. Now, like with our move tool, we also have the rotate tool. So if I press E to go to the rotate tool, you can see here that we have this sphere overlaid on our cube, and this allows us to rotate along the three different axes. So if I click and drag on the green circle, this is going to rotate us along the y-axis. You can see here in the inspector that is being modified. Now, just like in 2D, our rotation is being measured in terms of degrees, okay? So don't worry about a difference in that way. Same thing for the z-axis, we can rotate along that, and we can rotate along the x-axis as well by clicking and dragging around. Now we can also just click anywhere in this little sphere, and that is just going to rotate based on our current perspective, okay? So based on our current camera angle. So if I, for example, move the camera up over here and then click and drag on it, you can see the cube's going to sort of rotate as if there is a pole going from the center of our camera through the cube. It's spinning around that. Now the next one is going to be the scale mode. Now if we press R or click on the button up here, that's going to take us over to our scale tool. And just like in 2D, we can click and drag along these axes to change the size of the node. Likewise, we can just click and drag anywhere to uniformly increase it or decrease it in size. And like with our move tool, we can click and drag on these little squares to basically scale along two specific axes at a time, which is pretty handy if you wanted to create walls, for example. You can just click and drag like that and move that in a little bit, and there you go, you've got a nice thin wall. Likewise for a ground, we could simply just click and drag on this green square, drag that out, and then shrink it down vertically a little bit, and there we go. In a matter of, a second or so, we have a floor ready for us to use. Okay, so in between now and the next lesson, I have a bit of a challenge that I want you to complete. What I want you to do is create a snowman using multiple MeshInstance3D nodes, okay? You can see in the example on the right, we are using 3 spheres and 1 box. Now, I want you to use the move, rotate, and scale tools to basically position, change their orientation, and change their sizes until you get something that matches the image on the right. So have a go at that, and I'll see how you're done in the next lesson. Okay, so I hope you had a go at that challenge. So let's go over how we can actually do this. So I'm actually going to use the mesh instance we have right here for the arms. So I'm going to rename this node by double clicking on it to be arms. And then what I'm going to do is I am basically just going to shrink it down in size. So I'm going to shrink it down vertically, and then I'm going to decrease the width, and then maybe make it a bit longer as well. And then we'll move it up here. Next, we need to create the 3 spheres for the legs, the torso, and the head. So I'm going to go ahead and create a brand new MeshInstance3D node. I'm then going to go to the inspector, set the mesh property here to be a new sphere mesh. And this one I'm going to rename. So I'm going to double click on the node, and I'm going to call this one legs. Then I'm going to press R to go to the scale tool and increase its size like this. Then I'm going to duplicate it with Control D, move it up here, and then decrease its scale a little bit there. Now I can then move the arms down. So if I press Q, select the arms, I can then move them down. And also, if we have the select tool, you'll see that we actually have both the movement and the rotational tools visible to us. So we don't actually have to go over to the move and then to the rotate tool. We can just stick with the select tool, and that's going to allow us to modify those properties like so. So I'm just going to increase its size here. There we go. And then finally, secondly, I'm going to rename this middle sphere to be torso. And then I'm going to duplicate it one more time, move it up, and shrink it down for the head. And there we go. Now we have our actual snowman created. Okay, so another thing I actually want to go over is then what we can do is to make it a single, sort of not a single model, but a single thing that we can move around. Because let's just say we want to have this as a character in our game. How would we move this around? Well, we'd select it and we'd move it around, but that would only move the legs. You can see the issue here. So what we're going to do is we are going to create a brand new node. So I'm going to click on the plus here and I'm going to search for node 3D. Now a node 3D, if we create that, this is just going to have a little circle icon, and if we look in the inspector, you can see that its properties are a lot slimmer than the mesh instance. The reason why is because this node 3D doesn't have any extra things attached to it. It isn't there to render anything to our screen or have any specific behaviors. All it has is this transform here, which can denote a position, rotation, and scale, as well as some other boilerplate properties. So what I'm going to do is I'm going to rename this node here to be Snowman. And then I'm going to select the head, torso, legs, and arms and drag them in to be children of Snowman. Now, if I select the snowman and move it around, you can see that all of the other 3D models, those all move with the main parent. And if I rotate the parent, you can see that they will all rotate as well. And if I scale, they will all scale up as well, which is great. Now, at the moment, we have only really been working with these plain white spheres and cubes. So in the next lesson, we are going to be looking at the concept of materials, which allow us to change the visuals of our 3D models. So thanks for watching, and I'll see you all then. Hey everyone, in this lesson we are going to be exploring materials inside of Godot. Now, what is a material? Well, essentially a material is something that we can apply to a 3D model to basically change how it looks visually. So by default in Godot, whenever we create a new 3D model or a mesh instance, you can see that we have this white appearance to the model, and this is essentially just a default material. So you can see it just has a white color. It's not really reflective at all. It kind of just looks pretty simple. Well, what we can do is create a new material that can change its color. It can change how reflective it is, how metallic it is, how transparent, if it glows. We can apply textures, normal maps, all sorts of different things to customize the visuals so we can design them in a very specific way. So how can we create a material? Well, I'm going to go down to my file system and I'm going to create a new folder here. So I'm going to right click, go new folder, and I'm going to call this one materials. Now inside this materials folder, what I'm going to do is right click on it, go over to create new, and then go over to resource. Now, a resource is essentially a file that we can create in Godot that can represent many different things, such as materials, tile maps. It can represent animations, all these different things as we can see here. Now, I'm going to search for material. And what you'll notice is that there are a lot of different types of materials. Well, for us, we want to create a standard material 3D. This is basically a material we can just slap onto a 3D model and change its look. So I'm going to create one of those, and I'm going to call this one my first material, or you can call it whatever you wish. Now, if I open up the materials folder, you can see we have the material file right here. And if I select it, you can see over in the inspector, we suddenly have all of these different properties that we can modify. We have a little preview at the top showing us what our material looks like. And by default, it is going to basically be the exact same material that is applied to our 3D models here. Now, if I go over to albedo, for example, this is where I can change the base color. So if I click on this little white color property, it's going to open up with this color picker. So I might want to change the values here so we can just experiment with those. Maybe I want a nice reddish material like this. And you can see the little preview here has changed. But we don't actually see it inside of our game. So how can we change that? Well, what I'm going to do is I'm going to select my material and drag it on top of the model. And you can see if I'm hovering over it, it's basically previewing what that material is going to look like. So if I let go, now the material has been applied to the model. Now, if you want to apply a material in a more technical way, what we can do is select the 3D model. Then in the inspector, we want to go over to where we have Surface Material Override. Open that up, and you'll see there is a little empty field here. We can simply then just drag in the material to that property. So I'm going to go ahead and attach this material to all of the different spheres and boxes here. And now you can see our snowman is red. But there are many other properties that we can modify on this material. If I double click it again, for example, and go to the inspector, I'm just going to increase the size of this window here a little bit. You can see there are many things we can change. If I go down to roughness, roughness basically defines how reflective this material is. At a roughness of 1, that means it is not reflective at all. You can think of material like wood or carpet, okay, that would have a roughness of 1. But if I bring this slider down and have a look on the left, you can see that our model is becoming more and more reflective. We can see the little specular highlights coming through. So if I bring that roughness down to 0, this is essentially like glass or like a mirror. Whereas if it's something in the middle, this could be something such as plastic, okay? And you can see already the material, it changes how we perceive the model. Now, another property we can modify is just above in the metallic property drawer. You can see we have a metallic property here, and this basically defines how metallic the material looks. It's kind of hard to exactly explain what this looks like. The best thing I can say is it makes it look more like metal. So if we drag this up from 0, you can see that our model all of a sudden appears as if it's made out of steel or aluminium, something like that, okay? And again, it's hard to really explain what this visual is, but I guess the easiest way is it looks more metal. Something else we can then modify is the transparency, because let's just say we want our snowman to be able to go invisible. Well, for that, we might animate its transparency so it fades out. So first of all, we have to go up to the top where we have the transparency section, and here we can change exactly how the transparency is calculated, okay? So I'm going to go to where it says transparency disabled, and change that from disabled to alpha. Now, alpha is basically a word we use for transparency, okay? Now, you may notice that the arms of the snowman are kind of just appearing through, and it looks a bit strange. To fix this, we can simply go down to the depth draw mode and change that from opaque only to always. And this simply makes it so that whatever we are seeing is what's being rendered, so we don't actually see the intersection of the arm here. Now, down inside of our Godot, we can go back to that original color property and open it up. And you'll see here we have our R, G, B, and A values, red, green, blue, and alpha. Now, if I drag down this alpha value, what you'll notice is that our transparency will decrease, okay, or increase in transparency. So this is a way of basically making our 3D model see-through. So we can do something pretty handy like this, okay? If, for example, you wanted a force field around your player, you can have a nice transparent color like that. Now, the one final thing I want to go over, and I'm just going to reset the alpha back to full, and I'm just going to disable transparency. So up here in transparency, I'm going to make that disabled. We are going to essentially explore the concept of textures, because with 3D models in your games, you probably want to apply a nice visual to them. You might have a texture of perhaps a tree or a texture of grass that you might want to apply to the ground. And to do this, we're just going to go down to where we have albedo. So we're going to go back to albedo. This is quite a common area we're going to be exploring. And down at the bottom, you see we have texture. Now, what I'm going to do is open up my sprites folder and drag in the player PNG like so. And now I've applied the texture. And if we go over here, we can see the texture like so. You might be wondering why it is red, and that is because the texture's color is being multiplied by the color up here. So if I change our albedo color back to be white, you can see we now have just the raw texture color. And it does, of course, look a bit strange because we are wrapping this 2D texture around a sphere, which is a fairly tricky thing to accomplish. But there we go. Those are the basics of creating materials in Godot. Okay, now as a bit of a challenge, what I want you to do is create 4 new spheres, and on each of them, I want you to create the following materials. I want you to create a standard purple material. I want you to create a material that is a metallic green. I then want you to make a material that is a transparent or translucent red, and then finally a material that has a texture. So have a go at that, and I'll be right back in the next lesson to see how you've done. Alright, so I hope you had a go at the challenge. Let's now go ahead and complete it. So what I'm going to do is I'm going to go ahead and create 4 new spheres. So I'm going to create a new MeshInstance3D node. I'm going to call this one Material Sphere. I'm then going to go ahead and just move it out over here. Next, we need to create the actual mesh. So in the inspector, I'm going to go over to the mesh property and set this to be a new sphere mesh right here. There we go. I'm then going to move this over here a little bit, and if you want to snap it, you can hold down Control, and that's going to sort of snap it to 1 meter increments. So I'm just going to move it over here, duplicate it, move it there, duplicate it, move it over here. We might actually not do the snapping, might just move it like that, and like that. There we go. So now we can create our 4 materials. Now for the first one, we want to create a new pink material, or a purple material. So in my materials folder, I'm going to right click on it, go create new, resource. I'm then going to search for standard material 3D and create that. I'm going to call this one, I'm just going to call it purple and click save. Now I'm going to select the purple material by double clicking on it. Then in the inspector, I'm going to go down to albedo and then the color property. I'm going to open that up and I'm just going to begin modifying the colors. Now you can work in terms of RGB values or HSV, which stands for hue, saturation, and value. Hue being the color, saturation being how strong it is, and value being the light, the brightness. So I'm just going to go ahead and adjust this to a nice purple color, something like that. Now I can simply drag this purple material onto the sphere to have it applied. Now, this is one way of creating a material which basically saves it as a file to our hard disk. But what if we just want to quickly make a material that we don't really plan on reusing in the future? Well, we can create something known as a sub-resource, which is a resource that lives within a node and isn't saved to our file system. Now, like I said, the pros of this is that we don't have to go in and create a new resource here in our file system, but the cons are that we can't really reuse it unless we save it to our file system. So this is just an alternative way of creating a material. Now, if I go over to the inspector, open up the surface material override section and go down to where we have the empty property here, I can click on it and then select new standard material 3D. Now that material has been created, and if I click on it, we can then edit it inside of the inspector, inside of the node. So for this one, we want to create the metallic green. So I'm going to go to albedo, color. I'm then going to change this to a green material, something like that. I'm then going to go down to metallic, and I'm going to bump this up to probably about 0.9. And then down in roughness, we want to have that nice sheen. So I'm then going to go over to roughness and bring that down until we get a nice metallic look, something like this. Now then, for the next two, we are going to create a transparent red and then a texture. So for the transparent red, I'm going to select the sphere. I'm going to go about the same way of creating the material in the inspector for this one. So I'm going to go surface material override, select the empty property, go new standard material 3D, open that, go down to albedo, change the color here to be a red. There we go. Might make it a bit of a lighter red, something like that. Then I'm going to go to transparency and change the transparency from disabled to alpha. Now, if I go back to my albedo color, I can bring down that alpha value to about halfway, and then you can see the sphere is now transparent. And if I look at it, if I look at the other spheres through it, we can see them behind, okay, which is pretty nice. Then finally, for our last sphere, we want to create a material that has a texture. So I'm going to select this material, I'm going to go over to surface material override, create a new material, open it up, I'm going to go down to albedo, And then inside of the texture property here, I can drag in one of my sprites. Now, you can alternatively import a texture and then just drag that on if you want the whole texture applied. So I might just drag on the player, and there we go. Let's rotate it around so we can actually see the face. There we go. And those are our materials that have been created. So what I want you to do now is essentially just experiment with these a bit more. Look at all the different properties that we might not have gone over. Okay, there's other things such as emission, rim, clear coat, all these different things that you can do your research on, and honestly just go through, start experimenting with what these different things do. As you can see, rim here, it's a pretty interesting effect, so you can of course experiment with that, experiment with all these different settings just to get familiar with how materials work in Godot and the different possibilities that they provide. Now, one more thing before ending the lesson. Let's just say you have created a material here in the inspector, okay, a sub-resource, but all of a sudden you're like, actually, I want to save this as a file to my file system. Well, what we can do is we can simply click on the little down arrow here next to the material and go down to where it says save. Then what we can do is choose the folder we want to save it to. I might call this one texture material and click save. Now that material has been saved to our file system and we can then reuse it on other 3D models. So thanks for watching, and I'll see you all then in the next lesson. Hey everyone, in this lesson we are going to be looking at lighting inside of Godot. Now, when you are working with 3D games, one of the most important aspects when it comes to developing nice looking visuals can be your lighting. Lighting allows us to set the mood and change the atmosphere of our scenes, as well as displaying shadows to make it look, I guess you could say, more realistic. So in Godot, we have a number of different ways of introducing lighting, and we're going to go through the main ones here. So first of all, I've gone ahead and created a brand new scene where I've created basically a floor and a sphere here to act as our recipients for the light, okay? Now you can see by default, we do actually have a light that is emitting from our sun up there in the sky. It is basically casting light upon our sphere and our ground, and since our ground is behind our sphere, it is casting a shadow. But if I were to play my game, you wouldn't really actually be able to see anything because by default, when we press play, this light isn't actually there, okay? Our viewport that we are viewing right now has a few built-in sort of presets such as lighting. So let's go ahead and manually add in a sun. So if I click on the plus right here to add a new node and I search up light, you'll see down here we have 3 different types of lights in 3D: directional light, omni light, and spotlight. A directional light is basically what acts as our sun. So if I go ahead and create that, you can see that our environment is going to change. Now what I'm going to do is I'm going to drag this directional light up a bit so that we can see what is happening. And you can see that there is this little arrow pointing over along the Z direction. This is essentially the direction of the light. Now, directional lights are used for sort of overall lighting for like a sun or a moon, or if you want a sort of just a mood lighting, just blasting down on your scene, you can use a directional light. So what happens then is if I go ahead and rotate this node, you can see that our lighting is changing, and especially on the sphere here. Look what happens as I move the light around. Basically, the arrow is pointing in the direction that the light is shining. If I point directly down, you can see that the sphere is lit from above, and if I put it on an angle, it is lit from an angle. Now, what you may notice is that there is no shadow, and that is because by default in Godot, lights do not cast shadows. And the reason why is because when it comes to computing lighting, shadows can be one of the most expensive things because there are lots of different steps that are involved in casting shadows. So by default, shadows are disabled. But of course, if we have a sun, we probably want to have shadows to be able to gauge distance and have it look a bit realistic. So what I'm going to do is with my directional light selected, I'm going to go over to the inspector and then go down to where we have the shadow options here. And I'm just simply going to enable that. And now, as you can see, we have a shadow enabled. So now if I go ahead and begin rotating this light again, you can see that the shadow is going to move with the direction of the light. Now, the directional light, it does not matter where it is positioned. As you can see, I can move it around, but the lighting does not change. That is because the directional light basically only relies on its orientation to determine what the lighting looks like. Now, you might have your game set on an alien world where the sun might be green or it might be purple, so how can we change the color of the light? Well, if we go over to the lighting options, you can see here that we have a color property. If I go ahead and modify that, you can see I can change it to be a reddish sort of light. I can make it pretty much whatever sort of color I want. Then what we can do is directly below the color property, we have energy. And energy basically defines how powerful the light is. As you can see, if I bump it up, the light suddenly becomes almost blinding. It's glowing off the surface, as you can see. And depending on your game, you might want something like that. I'm just going to go ahead and switch this back to white. In fact, I'm going to make this a sort of yellowish white, something I think about there. So it sort of simulates sunlight a bit more. Now, the next form of light we're going to look at is what's known as an OmniLight. So if I go ahead and create a new light, we are going to create an OmniLight 3D. Now, I'm going to create that. And this OmniLight 3D, you will notice, has basically a sphere around it that defines the direction. Now, an OmniLight is essentially a light source that emits from all directions around it. Think of something such as a fire or a candle, or perhaps even a light bulb. You light it up, and everything around it in view gets illuminated. Now, to better display this, I'm going to go ahead over to the light panel, and I'm going to change the color to a nice vivid color so that we can see this in action. I'm going to change it to green, okay? Now you can see that when I move this around, we have this sort of green light that gets emitted. I'm going to make it a bit more powerful as well, so I'm going to bump up the energy here, just so we can see it a bit better. And then what I'm going to do is hide the directional light. So with the directional light selected, you can see here in the scene dock, we have this little eye icon that says toggle visibility. This basically enables or disables the node. So I'm going to disable the directional light so that our OmniLight is the only thing illuminating our scene. In fact, I'm going to make the ground a bit bigger as well. So I'm just going to drag that out like so, and there we go. Now you can see our OmniLight basically is a sphere of light that is emitting in all directions around it. Likewise, we can go over to shadow and enable the shadow on this so that it can then cast a shadow. And I think that looks pretty cool with the sphere there and the shadow going off into the distance. Now, we can also change the range of this light by adjusting the sphere. And if I zoom out, you can see there is this little orange dot. If I click and drag on that, this is essentially changing the range of the light. So if you want something that's very small, maybe like a candle, you can bring it down to have a much shorter range. Okay, so that is a look at the OmniLight and directional light. Now finally, we are going to look at the third lighting type, which is spotlight. Now, let's go ahead and create the spotlight here. And this basically acts as a cone of light, okay? You can think of something like a street light or a torch you might hold in your hand. So as you can see, we have a cone basically defining the shape of the light. And if I aim this at a bit of an orientation down here, you can see it's sort of emitting in a cone down to the ground. I'm going to disable the OmniLight by clicking on the little eye icon here, just so we can have the spotlight as our full attention. I can move it over here to where the cube is. I'm then going to enable shadows on it as well, so we can sort of have a bit more depth. And with this spotlight, we can adjust a few things. We can first of all adjust the angle of the light by clicking and dragging on the outer edge of the cone, as you can see here. We can also adjust the range by clicking and dragging on the center dot. This is just going to change how far the light will emit. And of course, if we go over to light, we can then change the color. So we might make this a nice bluish, I will make it a nice purple. And then we can of course change the energy, which is the brightness. So there we go. That is a quick little look at lighting inside of Godot. Hey everyone. In this lesson, we are going to be looking at how we can create a camera inside of Godot in 3D. Now, a camera is essentially going to be our viewport when playing the game. Because right now, inside of the editor, we can fly around and develop our scenes by clicking on nodes, moving them around, adjusting all their properties. But when we press play, we need a specific node that is going to represent our viewport. Now, if I go ahead and play my game now, and I click on the play button, what you'll notice is that we have our 2D scene being rendered. even though we are currently in our 3D scene. The reason why is because earlier on we did actually set up our 2D scene to be the default, and that's what happens when we click Run Project. But if we go ahead and click on this button here, Run Current Scene, this is going to launch our current scene. So if I click on that, you'll see that we open up in this new window, but we don't see anything. And the reason why is, of course, because we don't actually have a camera that has a definitive position or rotation. So what I'm going to do is I'm going to go and click on the plus icon here to add a new node, and I'm going to search for Camera 3D right here. I'm going to click Create, and that is going to create a new node, which if I then move back, you can see we have this sort of purple box that is going to represent the angle and direction of our camera. And with it selected, we can look over in the inspector and see a little preview of what the camera is actually seeing. So we can then adjust our camera's position and even its rotation to match what viewport we want for our game. So if I put it like here, save that, and then if I go and click on Run Current Scene, or F6 as the shortcut, that is then going to use that camera as what we are looking at. Now, you may notice that our scene looks a lot different than what it does in the preview, and that is because inside of the Godot editor, there is first of all a skybox that it puts in for us, and it also has a default directional light. So if we go ahead and create that now, I'm just going to go ahead and create a directional light 3D. I am just then going to adjust its direction, so it's going to be aiming down sort of in this direction. We can then even go and enable shadows. And there we go. So now if I press play again, you can see that we have that lighting enabled. We're not going to worry too much about a background right now, as we are just focused on setting up our camera. So what other things can we change about our camera? Well, we can of course move it around, so we might want to have a bit of an overhead view here. We can then rotate the camera down and then move it like that. And as you can see, we can then save that, press play, and we now have a downward looking view. Likewise, we can adjust other options such as our field of view. So if I go down in the inspector, you can see here we have a lot of different properties to modify. My FOV right here, field of view, basically determines the angle that the camera is going to capture. By default, it's 75 degrees, but I can go ahead and increase that, and you can see in the little preview here that our viewport suddenly gets stretched out, or if I bring it down, it gets zoomed in. So we can zoom in a little bit here, maybe adjust our camera a bit more, and then we have a nice little viewport like so. Okay, so have a go at adding cameras to your scenes and placing them around. And while we're at it, let's look at also how we can create a 2D camera. Because just like in 3D, we might want to be able to move our viewport around inside of our 2D scene. So I'm going to hop back over into our 2D scene here that we were developing earlier on, and I'm going to go ahead and create not a camera 3D, but a camera 2D. I'm going to click create, and that is then going to create this node here, which is essentially this large purple box that we can then move around and position. So if I put it right here, save it, and then press play, you can see that whatever the camera is looking at is going to be rendered. Now, how do we zoom this in and out? We can't really move it closer or further away since there is no such thing as depth in 2D. Instead, what we're going to do is go down to where we have the zoom property. And with the zoom property, right now it is set to 1, meaning that 1 pixel in terms of Godot units is going to represent 1 pixel in our game window essentially. But if I bring this down to 2, that means we are 2 times zoomed in. So if I save that and press play, you can see we are now zoomed into our game here. Likewise, I can bump that up to 4, and that's going to zoom it in even more. I can press play, and you can see we are zoomed in quite a lot. Likewise, we can also make this a number such as 0.5, and that's going to zoom our camera out quite a bit. But for default, I'm just going to set this to be 1. So that is a look at a camera 2D as well as a camera 3D. Feel free to experiment with both of these and just get comfortable with positioning the camera, and in 3D even rotating it around and changing the field of view to get the correct view that you want. Hey everyone, in this lesson we are going to be looking a bit closer at our game window, and by this I mean if we go ahead and run our current scene, you'll see that it opens up this exclusive window here with our game running. Now, this might be a bit awkward as we might want to go around our editor to look at a few things, but then the game window sort of disappears because it's its own application that's being run. So what we can instead do is actually have our game window embedded into the engine itself. Now to do this, I'm going to stop playing our game, and then at the top, I'm going to go over to the game dock window here by clicking on game at the top. Then you can see we have these bunch of options at the top bar here. I'm going to click on these three dots on the far right called embedding options, and I'm going to disable make game workplace floating on next play. Now if I go ahead and run our game, you'll see that instead of opening up a new window, our game is instead being run inside of this little window here, which is pretty good as we can then sort of navigate around, click on stuff, look for our file system. But this game window also provides some very handy tools. Let's just say we are making our game and we want to check to see the value of something, or we want to make sure to see the position of something is in the right place. Well, we can't really do that because if I click on the sphere here, it's not going to do anything. And if I hop back into the 3D scene here, well, this isn't a representation of what our game currently is while playing it. So what we can do is go back to the game window here of it playing, and at the top of the screen you can see we have these three buttons: input, 2D, and 3D. By default we are set to input, which basically means that this is allowing the input from our keyboard and our mouse to play the game. But if I click on 3D, you can see what this says. It says disable game input and allow to select node 3Ds and manipulate the 3D camera. So if I click on this, now what happens is I can actually select nodes inside of the game window here by clicking on them. And as you can see, I clicked on the sphere. It then highlights its properties here in the inspector. And if I go over to the position, for example, I can then modify its position just like that. So I can actually change what is going on in the game by modifying it in the inspector by jumping over from input to 3D. So we can do that with a bunch of things. I can select the sphere here, for example, and then I might want to increase its scale. So I can do that like so, and then I can keep playing the game. Okay, so this is different than the 3D view. You can see if I go back to the 3D view, nothing has changed because this is basically the blueprint for our game. This is where we lay down all our levels and our building blocks, and then when we play our game, this is where things are running. This is where our code runs and where we can move our player around, have our music playing, have all our effects going off. But there might be times where you want to check, for example, certain things in the inspector for a specific node. And in that case, you can click on 3D up here to switch over to the 3D editing mode. So we can select nodes, view their properties, and even modify them. Likewise, I'm going to stop playing the project here. If we were in a 2D scene, such as this, and we press play, we can instead click on the 2D button, and this is then going to allow us to select our 2D nodes, as you can see here. But if you do have inputs for moving characters around, you can just click on input again, and that will allow you to regain control of your game. So that is a quick look at the game window here, and likewise, if you ever wanted to pause your game, for example, you might want to pause because there's something you want to check, you can click on this button at the top left corner to essentially pause the game. And if you click on this button to the right, we can actually go frame by frame through our game. But of course, we're not really going to be exploring this here because, well, everything in our game at the moment is pretty static. Then of course, you can click the pause button again to continue playing. Now this here is a tool that you can utilize to begin debugging your games. If there are any issues with it that you might be encountering, you can of course use the game window to pause it, go frame by frame to see where something went wrong, or of course you can select nodes during play to modify and view their properties. Hey everyone, in this lesson we are going to have a look at scripting. We're going to explore what scripting is and how it can be used. So first of all, what is scripting? Well, this is essentially code. If you've ever heard of people talking about coding or programming, writing down all this weird cryptic text and then running it to do something, that is essentially scripting, okay? It is how we create the gameplay behaviors and logic for our games. Now, a script is merely the name for a file that we can create in our file system, okay? Think of this sort of like a text document, okay? And this contains all of our code. Now, with this script file, we can then attach it to a node. For example, if we want a script to control our player's movement, we might attach a player script to a player node, and that would then control that functionality. If we wanted to have an object that we want to, for example, maybe rotate around over time, like a windmill, we might create a rotate script and then attach that to the windmill to have it rotate around, okay? So the scripts are directly affecting the node that it is attached to. Now, let's hop over into Godot and begin looking at how we can actually create a script and attach it to a node. Okay, so here I am inside of Godot. Now, what I'm going to do is I'm going to go ahead and create a brand new scene for us to experiment with. So I'm just going to go new scene here, and I'm going to create a 2D scene. I'm then going to save this scene. I've also gone ahead and created a scenes folder, which contains all of my scenes. And I'm just going to call this one Intro to Scripting, and save that there. Great, so in my scenes folder, I have all of my scenes here. Now also, I'm going to go ahead and create a new folder in the file system to store my scripts, because right now we don't have a folder for that, and it's good to organize stuff in folders. So I'm going to right click, new folder, and I'm going to call this one scripts. So this is where we're going to store all of our scripts, which contains our code. Now, we are just going to be creating a script to learn the basics, so I am going to select my root node here. And then over in the inspector, down right at the bottom, you'll see that there is a property called script, and right now it is set to empty. If I click on the empty field here, I can select new script, and here I can give it a name and choose the path to save it in. I'm going to click on this little folder icon, and then I'm going to navigate up to my scripts folder, and then here I'm going to give it a name. So I'm going to call it Intro to Scripting, and then the .gd at the end is the file extension for a script, okay? The language we are using is known as GDScript. So I'm going to click Open. That's going to set that up there, and then I can click Create. So that is going to create our script file down inside of our file system. You can see it has this little gear icon, basically denoting it as a script. And then in our center viewport, it is going to switch over to the scripting window, okay? At the top, remember, we have 2D, 3D, and then script. Now, this screen here is where we are going to write down and edit our code. Now, essentially, a script is a text file, okay? You can think of it as sort of like a text file like Notepad or Word, but instead of writing down words, as if you're writing a letter or writing a book, we are instead writing down code. Now, you could be thinking, why don't I just use Notepad? Why don't I just use Word to write my code? Well, the reason why is because when it comes to coding languages, and the coding language we use in Godot is GDScript, we have to write very specific words in a specific order and even indent them depending on what we want them to do. So using this script editor here, this is going to automatically highlight our code. As you can see here, right now we have just one line which says extends node 2D, and you can see extend is in red and node 2D is in green. Basically, when we write down our code, it will all be colored and formatted automatically for us so we can easily see what's going on. And as you might have autocorrect on your phone or in your word processor, this script editor also has the ability to tell us what we might want to write, for example. So we could start typing something, a little window will appear, and it will have all the different possibilities for things that we can do. So let's have a look around this window. So in the middle, this large area here is basically our text editor. So I can come in here and just start typing down words, but of course, what I've written down here is not code, so it's going to return errors, as you can see with this red blocks appearing, basically saying, hey, this is not code, I'm not able to understand what's going on here. But yeah, this is where we'll be writing down our code. On the left hand side is where we have a list of all of our scripts. So if, for example, you are working on a game, you probably want to jump between multiple different scripts. So that is what this list here is. But of course, we only have one script, so that is why we have the one thing here. And we can just click on them to navigate over. Now, before the next lesson, just a little bit of information about the language that we are using here. Now, when it comes to programming or coding, we use what is known as a coding language or a programming language. Like when you have English, Spanish, French, okay, we communicate in different ways. So too can we communicate with the computer in different ways. Now, there are hundreds and hundreds of different coding languages out there, okay? And the one we use inside of Godot is known as GDScript. Now, if you have any experience with Python, then GDScript is going to feel very familiar, okay? It borrows a lot of the same concepts and syntax as Python. But if you have no idea what Python is, and if you have no idea about coding at all, this could be perhaps your first time ever even seen code, that is fine. We are going to go from the very, very basics so that hopefully by the end of this course, you will have a fairly well-rounded understanding of the basics and the core logic of coding inside of Godot. Now, in the next lesson, we are going to explore the first concept of coding, which is known as variables. So thank you for watching, and I'll see you all then. Hey everyone, in this lesson, we are going to be exploring the coding concept of variables. Now, a variable is essentially a piece of data which we can define, read, and change the value of. Okay, so how does this work? Well, you can think of it sort of like a box, okay? The variable is a box and we can give it a name, for example, player health. And then we can assign a value to that box, or we can put a value inside of that box, such as the number 150. This is essentially a variable, okay? It is a piece of data that we are saving to our computer's memory, and at any time we can access it to read it, or we can modify it so we can change that value. So for example, with the player health variable, whenever the player takes damage, we will get that variable and subtract it by the damage taken, or if they get healed, we'll increase that number. And if we have, for example, a little bit of a health bar on our screen, we might want to read that variable to know how far to fill the health bar. So variables are used everywhere, and these are probably the core concept of coding. Now, there are also many different types of variables, okay? We can have whole numbers, decimal numbers, text variables, etc. The different types of variables you can have is pretty much infinite, okay? And we'll be exploring a few of them right now. So let's hop over into Godot and have a look at how we can create our first variable. So here I am inside of Godot, inside of my script. And if you want to zoom in, simply hold down Control and press on the plus to zoom in a little bit. I'll just do that right here. And to create a variable, what I'm going to do is I'm just going to go to a new line here. It doesn't really matter if you leave blank space or not. I just like to leave blank lines just to make it look a bit neater and to sort of differentiate the different sections of my code. So to create a variable, we have to do a number of things. First of all, we write the word var, so V-A-R, and you can see it highlights in red. Then we go space, and then we give our variable a name. So I might call this one score. Then we go equals, and we give it a default value. So what value do we want score to be at the start? I'm just going to go 0. So what we have just done there is created a variable, okay? We have a variable named score, and its value is equal to 0. We could perhaps even go equals 5, and now score is equal to 5. But what are we actually going to do with this variable? Well, we can change it. We can even print it out to the output here so we can see its value when we play our game. And to do that, I am going to write a little bit of code here, a bit of boilerplate code just to actually get things moving. It's going to be a bit confusing of what I write, but we are going to be going over what this is and how it works in a future lesson. I'm going to write func, F-U-N-C, which stands for function, and then I'm going to go underscore ready. And then I'm going to have an opening and closing parentheses. I'm going to have a colon, and then I'm going to press return to go to a new line. And what you'll notice is that on this line, my cursor is indented by 1 tab's width, or 4 spacebars. This basically means whatever code we have in here is basically a part of the ready function. So inside here, I'm simply going to go print opening parentheses, and write down that variable name of score. Now, if I save that and then go ahead and play, so I'll go up to this button here, run current scene. If I run that and we look down in the output, you'll see that we have the number 5 printed here. Okay, it might be a bit hard to see on the video, but the number 5 is printed in the output. So what's going on here? Well, essentially, this func_ready with the parentheses and the colon, this is what's known as a function. And a function is basically a block of code that we can call at any time. And the code we are running inside the ready function is going to be this, print score. Print is essentially a function we can call which prints whatever we have inside of these parentheses to the output. And since our score variable is 5, it is going to print out the number 5. Again, the idea of what a function is, we are going to go over that in a future lesson. Just know that whatever we put inside of this ready function, this will be run at the start of the game when the node is first initialized. Okay, that is what the ready function does. So we can also go ahead and perhaps change the value of score. Let's make it 10. Save that, press play, and you'll see down in the output, it now says 10. We can also change the value of score whenever we want. So for example, what I'm going to do is inside the ready function, I'm going to go up to its line, press return. Now I have a line above print, and I'm going to go score equals 20, okay? So inside the ready function, we're going to do two things. We're first of all going to change score to 20, and then we are going to print it out. So what do you think is going to appear in the output? Is it going to print out 10, or is it going to print out 20? Well, if I press play, you'll see that in the output, it prints out 20. The reason why is even though we have defined score with a value of 10, down inside of the code that gets run, we are first of all setting its value to be 20, and then we are printing out its new value. And that's another concept we need to go over, the order of execution. Order of execution basically defines what gets run when. So whenever a function is called, the code inside of it gets run line by line, starting from the top and then going down. So for example, if I go to a new line here before we change the score and print out score, here we are printing out twice. So what do you think the output is going to look like? Well, if I press play, you'll see that the output says 10, then 20. The reason why is because at the top of the script here, we have defined our variable as a value of 10. We are then printing that score, which is 10. We are then changing the score to 20, and then we are printing that value again. Now, between these two prints, the score has changed value. That is why we print out two different numbers. Okay, the order of execution. This line gets called, then this line, then this line. Now, when it comes to writing variables inside of Godot, we have the option of statically typing our variables. Statically typing basically means defining a data type for our variable. Now, what I mean by that is there are many different data types. We can have whole numbers, decimal numbers, true or false values, text. All these different variable types have what is known as a data type, basically telling the computer this variable is going to be a whole number, or this variable is going to be a decimal number, or this variable is going to be either true or false. And to do this, before we go equals on our variable declaration, I'm going to go colon, and then I'm going to write the word int. Now, what I'm doing here is defining the data type for our variable. Int stands for integer or whole number. So basically, we are telling the computer that this variable here is going to be a variable that represents whole numbers. So 1, 2, 3, 4, 5, etc. Now, we can also go ahead and create some other variables of different data types. So for example, we might want to have a variable called move speed. So I'll go move speed. This might be of type float, and this is going to equal 2.53, for example, okay, a decimal number. That is what float. Whenever we say float, we are basically meaning decimal number. Likewise, we can have a variable representing true or false. We can do this. We might call this one game over, and we define the data type as BOOL, bool, which stands for boolean, okay? And we might give it a value of false, or we can give it a value of true, okay? And you can see true and false are highlighted in red. And then finally, we might want some text. So I might go variable, I might call this one ability, and this is going to be of type string with a capital S, and this is going to be equal to, let's just say slash. But that is going to result in an error because in order to define a string, we need an opening quotation mark and a closing quotation mark. Then we can write down the string inside. And you can know if it's a string because its text will be colored in yellow, okay? And there we go. These are the 4 different types of variables we are going to be looking at. There's of course many, many more, and Godot has a bunch of other built-in ones that we can explore, but for now, I think these are a fine amount. Now, you can also see that I am writing my variables in a very strange way, okay? I'm going move speed underscore speed. Why aren't I just going move space speed, or just move speed like that? Well, there are many different ways of writing out text inside of coding, okay? The way that we define the names of our variables and the names of other things. What I'm doing here is known as snake case. Everything is written in lowercase, and spaces are, instead of having a space, because that will actually break the code, we are using underscores, okay? And this is just the general practice in Godot. We write names using snake case. There are, of course, other ways of writing variables, but really, different coding languages have different standards, and for GDScript, the standard is snake case. Alright, so in the next lesson, we are going to be looking more at these variables and how we can begin modifying them and even print them out to the output. So thanks for watching, and I'll see you all then. Welcome back everyone. In this lesson, we are going to continue on looking at variables. So, we've gone ahead and created a score variable, which is of type int, aka integer, meaning it is a whole number, and we have given it a value of 10. We have then created a variable called moveSpeed of type float, which is a floating point number or a decimal number, and we've given that a value of 2.53. And we've then created a variable called gameOver of type bool, which stands for boolean, and that is either true or false, and we can see it is written in red text here. And then finally, we've created a variable called ability of type string, which is essentially text, and we have given it a value of slash with opening and closing quotation marks to denote that this is a string. Then down inside of the ready function, which runs its code at the start of the game, we are first of all printing out score, which prints out 10. Then we are changing our score to 20, and then printing out score again, so it prints out 20. Now let's go ahead and delete these 3 lines of code right here, and we are then going to print out the other values. So I might go print, and then I'm going to print out move speed. I'm then going to print out game over, and then I'm going to print out ability, okay? Now do make sure that you are indented once in, okay? It should not be looking like this. If your code looks like this, then that is an issue and it's going to result in errors. Make sure that all the code you want to run inside of the ready function is indented, and if the indentation doesn't automatically happen, you can simply press tab on your keyboard and that should indent, okay? So now if I press play, we should see in the output we have 2.53 false and slash written down. Now to change these variables, it's pretty much done in the same process as for the score. So if I want to change the value of move speed, I can simply go move speed equals, and then I might go 0.1183, okay? Decimal numbers, you can get very intricate with the decimal. For game over, I might go game over equals true now. And for ability, I might make that equal to attack. Okay, so changing the value of a variable is fairly straightforward. Up here is how we define the variable, so we define that with the var keyword and then the data type, but to change it, we simply write down the variable name equals and then the new value. Okay, so if I save that and then play again, you'll see that we have those results in the output. Okay, so a bit of a challenge. I want you to create 4 variables to define a country. I want you to create a variable for the country name, for the population, for the highest altitude, and for whether or not it is landlocked. And what I want you to do is I want you to use one data type for each of these variables. I want you to use an int, a float, a bool, and a string. So figure out which data type you need to use for which variable, write them down, and give them a value. And I'll be right back in the next lesson to see how you're done. Alright, so I hope you had a go at the challenge. Now let's hop over into Godot and have a look at how we can set this up. Okay, so to start off, what I'm going to do is I'm simply just going to delete the variables that we have here already. And I'm also going to delete all the code inside of the ready function. Now, you'll notice that this is going to result in an error. And the reason why is because we can't leave functions empty. Okay, if we have an empty function, it's going to result in an error. So what I'm going to do is I'm simply going to write pass, P-A-S-S, inside of the function. And this sort of just acts as a placeholder content for the function, so it doesn't result in an error. Now we can write our variables. So starting with country name, I'm going to write var country name. And since this is going to be a name, it's going to be text, so we're going to make this of type string. Equals, and I'm going to call this one, I will make this Australia, okay? Then what we can do is create another variable for our population. Now, you can't really have a decimal point population, okay? You can't really have half a person or a third of a person, so this is going to be a whole number, so of type int. And I'm going to make this about 25 million, okay? Something like that. Then we're going to have highest altitude. So var highest altitude. Now, highest altitude, if we are measuring in terms of kilometers, for example, then we're of course going to be able to have decimals because you can have very fine decimal points with altitudes and those sort of measurements. So I'm going to make it of type float, and I'll have this equal to let's just say 228. And then finally, we have landlocked. So is this country surrounded by the ocean? That is either true or false. Okay, you can't really have a maybe. If a country is landlocked, it's either true or false. So this is going to be of type bool, and I'm going to make this equal to false. And there we go. We now have our 4 variables defined right here. Now down in the ready function, let's also go ahead and print them out. So I'm going to write print country name, and you can see when I'm writing down a variable, if that variable has been defined, it is going to automatically pop up in a little preview box as we are typing it down. So I can simply click enter and it's going to automatically fill in that variable name. Same thing, if I write down PRI, you can see we're going to have a list of all the different things that we can write here that start with PRI or contain PRI in the name. But I'm just going to write down print. And then we're going to do the same thing for the population. You can see population pops up in the list here. I'm going to hit enter. Then we can do, oops, not var. We can go print highest altitude. And then finally, we want to print landlocked. Okay. And then if we save that and then play the scene, you'll see that down in the output, we have all of those variables printed out, which is great. Now, we are able to print our values out, we're able to change their value here inside of the function, but what if we don't want to change their whole value? What if, for example, we have a score variable that we might want to increase by 1 when something occurs, or we have a floating point number that we want to multiply by 1.5, or we might have 2 strings, we might have a first name and a last name, and we might want to combine them together. How do we do that? Well, we have to use a concept known as operators, and we will be exploring operators in the next lesson. So thanks for watching, and I'll see you all then. Hey everyone, and welcome back. In this lesson, we are going to have an introductory look into operators. Now, what is an operator? Well, essentially, these are symbols that tell the computer to perform certain mathematical operations. If, for example, we wanted to increase the value of a number or increase the value of a variable, we would use operators to do so. Now, there are many different types of operators. In this lesson, we are going to be focusing on 4 main ones: addition, subtraction, multiplication, and division. Okay, if you ever wanted to manipulate numbers in any certain way, pretty much you can do everything with just these 4. Now, let's look at a little example. Okay, so for example, if we wanted to increase our variable by a certain amount, we would first of all declare the variable, and then to increase it, we would go num plus equals 2. Okay, so plus equals basically means we are adding whatever is on the right to whatever is on the left. Now let's jump into Godot and have a look at how we can set this up. So what I'm going to do is start off by creating a new variable here. I'm going to call this one score. It is going to be of type integer, so a whole number, and we'll make it equal to 0 to start off with. Now, let's go down to the ready function and print out score. Now, if we were to play our game, we would see score, the number 0, being printed in the output here. But before we do that, let's go ahead and modify score a little bit. So we already know that we can change the value of a variable by writing it down, then going equals, and then we can give it another value. So for example, here we are changing the value of score to be 10. But what if I don't want to make it equal to 10, but I want to perhaps maybe increase it by 1? Well, to do this, I can simply go score, then plus equals 1. Now, what I am doing here is I am essentially increasing score by 1. The plus equals basically means that the number on the right is going to be added to the number on the left. So what do you think is going to be displayed in the output when I press play? Well, if we press play, we can see that the number 11 has been printed, okay? Because we are setting our score to be equal to 10, then we are increasing it by 1. Likewise, we can also subtract. Now, subtraction is basically going to work in the same way. We're going to go score minus equals, and then we can enter in, for example, let's just say 5. So if I press play, we're going to have a number, if you can guess correctly, of 6. Okay, so we are subtracting 5 from the score. Now, for multiplication, it's going to be a bit different. Okay, you might be thinking, okay, we go, for example, score, then perhaps x equals 2 to multiply it by 2. But no, we do not use x for multiplication. Rather, in programming, multiplication is denoted by the asterisk symbol, okay? If that will be the alternate key on the 8 number, okay? So asterisk equals, and then if you want to multiply that by 2, we'll then go asterisk equals 2. So now, remember, up to this point, the number is 6. So hopefully, when we press play, the number will be 12. And there we go. And then, of course, to divide, again, this is a bit of a different symbol because, you know, when writing down mathematics, we have the division symbol, but we don't really even have that on our keyboard. So to divide, we're going to go score / equals, and then if we want to divide, let's just say we want to divide it by 4, okay? So then we can go /equals 4 to divide by 4. And if I press play, we can see that we have the number 3, okay? Because 4 times 3 is 12, and 12 divided by 4 is 3. Okay, so those are all the operators that we are using here to increase a number by an amount, to subtract a number by an amount, to multiply it by an amount, and to divide it by an amount. Now, we can also do the same thing with floating point numbers. So if I create a variable here, and let's just call this one perhaps speed, okay? And this is going to be of type float, and we'll make this equal to 5.5. Now, let's just say we are playing our game and we want our player's speed to all of a sudden double, okay? Well, what we can do is we can go speed and then multiply equals 2, okay? And if we print out our speed, well, that of course is going to be 5.5 times 2, so that's going to be 11. And there we go. But since we are working with decimals, we can also then multiply by decimals. So if I go speed times equals, let's just say we want to make it a very intricate amount. Let's just say we want to go 2.548. Okay, so we are multiplying it by a very intricate amount, and of course that result is going to appear right here. Likewise, we can also then divide by these intricate amounts. Okay, we can go speed, divide equals, and then we can divide that by perhaps 2.09, okay, and that's going to result in a very obscure number, okay? So you can see how we can use the addition, subtraction, multiplication, and division with not just integers, but floats as well. Now, you may be thinking about another thing, and that is, what about strings, okay? So, for example, a string is essentially text, and you may be thinking, hey, can't we just add text together? And you would be correct. So here what I'm going to do is I'm going to create a variable, and I'm just going to call this one, I will just call it text of type string, and we'll have this text just say first, okay? Now, if we go down here, what I'm going to do is I'm going to go text, which is that string variable, plus equals, and then we can simply give another string. So we can go then second, okay, just like that, and then print out the text. Now, what do you think this is going to look like? Well, if I press play, we are essentially going to stick those two strings together, okay? You can see first, second. So what we're essentially doing here is we are getting this text, this string, and we are simply slapping this other string onto it. Now, when it comes to using operators with Boolean variables, that's not really a thing because a Boolean can either be on or off, true or false, so we can't really increase, true by a number. We can't really multiply but false by anything. So that is kind of its own thing. But integers, floats, and strings we can add. And then with float and integers, we can use addition, subtraction, multiplication, and division. And hopefully now you can start to piece together sort of how you would utilize these things. For example, if in your game you have a health potion, the player would pick it up, and then we would go, for example, health plus equals 5 or something like that. And that is a way of increasing the player's health then. So you'll be using these operators all throughout your programming journey. Alright, so let's have a bit of a challenge. What I want you to do is I want you to create a money variable with a value of 10. Then I want you to do these 4 steps with each of them utilizing a unique operator. I want you to first of all add 5 to the money. I then want you to double it. I then want you to take 3 away from it. And then I want you to half it. So have a go at that and I'll be right back to see how you're done. Alright, so I hope you had a go at that challenge. Now let's hop over into Godot and have a look at how we can complete it. Okay, so let's start by creating a new variable here called money. I'm then going to make this a variable of type int, so it's going to be a whole number, and we'll make it equal to 10 by default. Then down inside of the ready function, what we're going to do is first of all add 5. So I'm going to go money plus equals, for addition, 5. Then we need to double it. Now, an easy way of doubling 15 is by just multiplying by 2. So we can then go money asterisk equals 2 to multiply by 2. We then want to take 3, so we're going to use subtraction. So money minus equals 3. And then finally, we want to half it. And to half it, we are going to divide money by 2. So money / equals for division 2. And then finally, we can print this out to see what the final result is. And you can make sure that you have the right number being printed out. So we'll save that, press play, and you should have 13 being printed out to the output. Okay, so we've looked at these operators, but there is also another way that we can utilize operators, okay? So what I'm going to do is I'm going to go down to a new line inside of the ready function, and I'm going to create a new variable called a, and I'm going to make this of type int, and this is going to equal to 5. Now you may be thinking, wait a minute, you're creating a variable inside of a function, and yes, you can actually do that. Variables can be created pretty much anywhere, but that limits what's known as their scope. Since I've created this money variable outside of the function, if I were to create more functions inside of this script, those functions would be able to utilize the money variable. But since this a variable has been created inside of the function, that means only the ready function can utilize this variable, okay? You can sort of think of it as its sort of vision, how far away it can see or be heard. If you're inside of a function, you're inside of a hole, so nobody outside really knows that you exist. Whereas if you are outside of the hole, everyone can see you and hear you. Okay, that's just a bit of a weird way of thinking about it, but that is essentially the basics of scope in programming. So with this a variable, what we can then do is, for example, go a, and then we could do something like a equals 10 plus 2. Okay, we can use addition, multiplication, subtraction, and division, not just to modify the variable directly, but instead to modify other things. So what I'm doing here is I'm setting a to be equal to the sum of this equation. So a is now equal to 12. Likewise, I can also go a equal 5 and then maybe times by 10. Okay, so then a is going to be equal to 50. And we can also keep stacking these up. So I could go 5 times 10 plus 2 plus 81 and then divided by 6, and that is going to work. Okay, that is going to basically calculate this equation right here and then equal the result to the a variable. Okay, so you can do all of this complex mathematics without really needing to know the answer yourself, as that is the point of having the computer do it for us. Now, we can also do this with variables. Okay, so for example, if I create another variable here called b, and this is of type int, I can make b equal to, for example, a times 2. So now the variable b is going to be equal to whatever a is at this point in the code multiplied by 2. okay, which is pretty cool. And then down here, for example, I could create another variable called c of type int, make that equal to 0, and then go c equals a divided by b, okay, and you can see how you can begin utilizing all of these variables in your equations as well, okay. Variables are not just static and have to take in raw numbers, as generally you will be multiplying things by variables. For example, if you want to move your player around, you would not just increase their position by 10 or increase it by 5, you would increase it instead by a move speed variable, which then defines how far the player moves, okay? So you'll be using variables in all these different ways all throughout your journey in all sorts of different scripts. And throughout this course, we will explore the different ways that we can utilize variables. So thank you for watching. And in the next lesson, we are going to be exploring the concept of conditions, okay? Being able to branch out our code. So thanks for watching, and I'll see you all then. Hey everyone, in this lesson, we are going to be exploring conditions inside of coding with Godot. So what is a condition? Well, conditions essentially allow us to check to see if a certain statement is true or false. Now, we can use, for example, the equality operator, equals, to see if two values are equal to one another. So if we go 5 equals 5, that statement is true. If we then go 3 equals 7, that statement is false because 3, of course, is not equal to 7. So what do we do with these things? Well, we then plug this into what's known as an if statement. If statements allow us to check to see if a condition is true. If the condition is true, then we run the encapsulated code. Otherwise, we skip over it. You can think of an if statement basically as a way of branching our code, okay? Because at the moment, we're sort of just running every single line of code that we come across, whereas if statements finally allow us to not run code or do run code if certain things are true. Okay, in this example here, we have a variable called a, which is equal to 5, and then we have an if statement that checks to see if a is equal to 5, and if so, we are printing condition is true. Now, if I change a to be equal to 6, that code, print condition is true, will not run. Okay, that line of code is only going to run if a is equal to 5. So now let's look at setting up some conditions inside of Godot. So I'm going to start by creating a new variable here. I'm going to call this variable score, and I'm going to make it an integer variable equal to, let's just say, 10. Now what we can do is go down into the ready function here, and we are going to create our first if statement, okay? I'm sort of interchanging between if statements and conditions. Basically, think of it as an if state checks a condition, okay? So here I'll go if, and then I'm going to write down the condition. The condition here is going to be score equals 10. And then we add a colon to basically denote this is the end of our statement. We then press enter to go to a new line, and you should see that it is in an indented, okay, 1 tab's width to the right. And here we can enter the code that we want to run when this condition is true. So here I'm just going to go print, and I'm going to print out score is 10. And there we go. So again, we have our if statement right here, which contains a condition, and this condition is checking to see if our score variable is equal to 10. Now, we are not going to go if score equals 10, okay, because in programming, equals and the double equals serve different purposes. A single equals sign is used for assignment, okay, this is what we would use to assign the value of 10 to score, whereas a double equals sign is used for comparison. And then down here, indented into the if statement, is the code that we are going to run when the condition is true. So if I press play, what you'll notice, of course, is down here, we have score is 10 printed to the output. But if I go ahead and change our score variable to maybe, let's just say 5, and run this, what do you think is going to be printed to the output here? Well, if you guessed nothing, then you would be correct, because this code is not being run because the above condition is not true. So an if statement only runs its code if the given condition is true. Now, we don't just have equals equals to check to see if one value is equal to another. We have a wide range of different ones. So let's check to see perhaps if score is greater than a certain number. So here we could then go if score, and then I'm going to do the greater than sign. So basically the right pointer like this. It should be shift full stop on your keyboard. Let's go greater than 5. Then what we're going to do is print out score is greater than 5. Okay, just like that. Essentially, what we are doing here is we are checking to see if the value on the left is greater than the value on the right. So if I press play, what should you see? Well, you're going to see nothing. The reason why is because score, first of all, is not equal to 10, and score is not greater than 5. It is 5. So if I change my score now to be 6 in the variable up here and press play, you should see that we do get score is greater than 5. Now, we don't just have to work with variable and number. For example, I'm going to create two variables here, one called A, which is going to be equal to 50, and one called B, which is going to be equal to 100. Now, down here, what I'm going to do is I'm just going to check to see if A is less than B, then print, and we'll just print out A is less than B, okay? Now, A is 50 and B is 100. So 50 is less than 100, so this print line is going to run. So if I play, there you go, we can see it is being run. Okay, and one final thing we're going to look at in this lesson is going to be the opposite of the comparison operator, and that is going to be not equals. So, for example, let's go down here. I'm going to write if A exclamation mark equals B. What do you think this condition is checking? Essentially, this condition is checking to see if A is not equal to B. So here I'll print out A is not B. And if I press play, we should see, since A is 50 and B is 100, A is not B gets printed out. But if I go ahead and change A to be 100, now A and B are equal. So what do you think is going to be printed out? Is this line going to be printed? Well, let's press play. And what you'll see is it is not, because the condition we are checking here is A is not equal to B. So if A is not equal to B, this code will run. If A is equal to B, this condition is false. So we'll simply skip over the code here. So lastly, let's go over what a condition and what an if statement is. A condition is essentially just a thing we are checking to see is true or false. Okay, is score equal to 10? Is score greater than 5? Is A less than B? Is A not equal to B? These are conditions that return either a true or a false value. Now, an if statement is essentially just checking to see if a condition is true, and if so, we run the encapsulated code, okay? So if statements and conditions work together. Now, in the next lesson, we are going to explore more about conditions and start to actually expand on different ways that we can utilize it. So thanks for watching, and I'll see you all then. Welcome back, everyone. In this lesson, we are going to continue looking at conditions and if statements. And in this lesson, we are going to explore the idea of not just if statements, but else if and else. So what am I talking about? Well, let's get started. So let's just say we have a score variable here and we want to grade our user, okay? We want to give them an A, B, C, or D grade based on their score. And let's just say this is a number that ranges from 0 to 100, okay? If they have a score above 80, they get an A. If it's above 30, they get a C, and anything else is a D grade. Well, let's go to my ready function, and here I'm simply going to go if score is greater than 80, then we are going to print out A, okay? Seems simple enough. So if I press play, since 100 is greater than 80, this is going to print. But what if we then want to give them a B, okay? Like I said, if their score is, for example, above 60, that is going to be a B. So then I could go to a new line here, go if score is greater than 60, well, then we can print out B, okay? Seems simple enough. Let's press play, and what you'll see is it says A and B. We don't want that. We want only one or the other. So what we can do is use what's known as an else if statement. Now, I'm going to write this out first, and then I'm going to go over how it works. So here we are writing if score is greater than 80, and then we have our code that is running. I'm going to go to a new line, go backspace to go in line with our first if statement, and then I'm going to write elif, which stands for else if. And then I'm going to write my second condition, which is score greater than 60, okay? Exactly what I done before. Then I'm going to print out B. Now, if I save this and press play, what you'll notice is that we only have A written out. Or if I change my score to, let's just say 70 and play that, you'll notice that it says B. So before it was printing out both values, but now it is only printing out one. Why is that? Well, it's the way that the else if statement works, okay? Basically, what our computer is doing is it is going line by line inside of the ready function. So we start with this condition, okay? If score is greater than 80, then print this. If that is not true, so if this condition does not get run, then it looks for an else if statement, okay? Down here we have elif, score is greater than 60, if so, print B. Basically, if the above condition is not true, we then check this condition, okay? And if that one's true, we then print. But if the above condition is true and it runs its code, we do not check any following else if statements, okay? You can sort of think of it as, if score is greater than 80, do this. Otherwise, if score is greater than 80, do this. We are essentially adding in an additional check if the first condition is false, okay? And we can actually stack these up. So we could then go elif score is greater than 30, then print C. So you can basically stack these else if statements atop one another and keep on going. Now, along with else if, we have one more, and that is the else statement. Okay, so we'll go else, colon, go to a new line, and then print out D. Now, else basically means that if all of the above if and else if statements have not succeeded, then whatever is in the else code here, we are going to run, okay? So if score is not greater than 80, if it's not greater than 60, if it's not greater than 30, then we will run the code inside of else. In that case, printing out D. So if I give myself a score of, let's just say 20, we should have D printed to the output, which we do. Okay, so that is a look at the if, the else if, and the else statements. And also, just in case you're wondering, yes, you can put if statements inside of if statements. So if you wanted to then do something like this, so we'll go if score is greater than 80, print A, and then we'll go if score equals 100, we can then print out, for example, perfect score, okay? So if I set my score here to 100 and then play that, it'll basically say A and perfect score, because if the first condition here is true, it runs all the code inside of it. And since the code here is an if statement, we then check that and then run the code if that is so. Okay, so you can stack if statements inside of one another like that. All right, so now I want you to have a bit of a challenge. I want you to first of all create a Boolean variable called game over. Then, if the game is over, print go to the menu to the output. Otherwise, print keep playing. So have a go at that, and I'll be right back to see how you're done. Alright, so I hope you had a go at the challenge. Let's now hop over into Godot and have a look at how we can complete it. So to start off with, we are going to create a new variable called game over of type Boolean. Now, we don't write out the full Boolean word, we just write down bool, and this is going to be equal to, let's just say true by default, okay? Then down inside of the ready function, we are going to basically write an if statement that's going to check the condition game over equals true, okay? Now, if game over is equal to true, then what we're going to do is we are going to print go to menu. Otherwise, so we can write else, we are going to print keep playing, okay? So now if I go ahead and press play, since game over is true, we should have go to menu printed to the output. Whereas if I change the value to be false, we should see keep playing printed to the output, which is what happens, okay? And again, you can use all sorts of different variables with conditions, okay? Here we are using a Boolean variable, The same thing could be used for a string. So if I create a string variable here, for example, called password, okay, and let's just say the password is 123, we can then perhaps have a condition that checks to see if password equals 123, and then we could have a print that says enter, okay? So if I press play, you'll see that since the password equals 123, we have enter printed there. But if I write down another number for the password here that is not 123, that enter print line is not going to run. So we can use both boolean, strings, int, we can use anything that we want when checking our conditions. Now, of course, you can't check to see if game over is greater than true, okay? The greater than, less than, those are really mainly used for numbers that have sort of a spectrum-based value, but things that have sort of a rigid value like text or true or false, those are great for using the equals, equals, or not equals conditional operators. Hey everyone, in this lesson, we are going to be exploring functions inside of GDScript. Now, functions are essentially reusable blocks of code that we can tell the computer to run. So we might have a function for making the player jump, we might have a function for adding score, we might have a function for updating our UI elements, okay? And in Godot, the engine has many built-in functions, and we are going to be looking at two of them as well as creating our own. Now, you may already be familiar with the ready function, which we have been using in the course so far. And essentially the ready function gets called once at the start of the game when whatever node the script is attached to gets initialized. But then we also have the process function. Now the process function, this gets called every single frame. So if you're having code that you want to, for example, move a player around on screen, you would use the process function to do that. So now let's hop into the engine and have a look at setting this up. Okay, so here in Godot, we've already got our ready function that we have created before. And what I'm going to do is basically print out ready inside of the ready function. And if I press play, well, of course, you'll see ready gets printed out once in the output. Now let's also go ahead and create the process function. So I'm going to go over exactly how the function declaration works in a second, but basically we go func func underscore process. And you can see when I'm typing out my function, you can see that this list pops up of all the different functions that we can use that Godot provides us. So we're going to use the process function here that in brackets says the word delta. I'm then going to print out process. Now, if I press play, what you'll notice is that the output gets filled up with these process lines. And if we look over to the right, we can see that there are over now 300, 400 messages being printed to the output, okay? Every single frame, we are printing process to the output. Okay, so that's pretty cool. I'm just going to replace this with pass for now. Same thing inside of ready. Now, what a function essentially is made up of is a number of things, okay? We first of all have the word func, which is basically how we declare that this line is the start of a function. We then have our function name in blue. Then we have an opening and closing parentheses. Now, this is basically where we put in what are known as our parameters. Now, a parameter is essentially information that can be sent over when a function is called, okay? And then we have a colon to denote the end of the function declaration. Then any code that below that is indented once is going to be a part of that function. Again, pass is essentially just a placeholder code, just so we don't have any errors for having an empty function. Now, process down here, you'll notice has a parameter, okay? It has a parameter called delta. And this is basically a number that gets sent over every single frame with process. And delta is essentially just the time between frames, something that you can use if you want. And this is actually of type float. Okay, so now let's look at actually creating our own custom function. So what I'm going to do is I'm going to go down to a new line here, and I'm going to write a function called welcome message. So I'll go func and then underscore welcome underscore message. Okay, remember, we pretty much want to use snake case with our naming conventions. So basically using lowercase letters and underscores where we would put a space. Now, why am I putting an underscore at the beginning of the function? Well, General practice in Godot is to basically have all private functions with an underscore and all public functions without an underscore. What is a private function? What is a public function? Essentially, private functions are functions that will only be called within the script, whereas public functions are functions that will be called from outside the script, okay? So essentially, welcome message is only ever going to be used and called within this script here. So we have an underscore. I'm then going to have an opening and closing parentheses, a colon, and then on a new line, I'm going to print out welcome to the game. Then what we can do is basically run our game. But what you'll notice is nothing is going to happen. And the reason why is because even though we have declared our function, we are not actually calling it, okay? And for a function to run, we need to call it. So how can we run a function? Well, I'm going to go to the ready up here, and I'm going to write down the function name, so welcome message here, and then add an opening and closing parentheses. You'll see that this line of code is now blue, and basically this is how we can call a function. So now if I press play, you'll see that the welcome message function is going to be called once at the start of the game. Now I could also go ahead and call this function down in the process function here. And so the welcome message is going to be called every single frame, okay? Now, let's have a look at creating something a bit more complex, okay? We are going to be looking at creating a function that can, for example, add two numbers together. So what I'm going to do is I'm just going to remove the call here, just write down pass, and I'm going to write a new function, okay? This function is going to be called add, and it is going to actually have two parameters. So to add in a parameter, we simply just give it a name. It can be called whatever you want. I'm going to call this one A, and then to add a second parameter, I'm going to go comma B. Now we can add as many parameters as we want. We could add maybe this, we could then maybe add a time parameter, we could add a delta parameter, all sorts of things we can add. So we have A and B. Now I'm going to add a colon, go to a new line, and inside this function we are essentially going to add these two values together and print out the result, okay? Something pretty simple. So I'm going to create a variable called sum, and this is going to be equal to A plus B, and then we want to print out the result. So we are then going to print sum. Now, if you have noticed, the print line of code is actually a function itself, okay? We have the function name, an opening and closing bracket with the parameter in the middle, okay? Print is essentially a function we are calling, which then logs a message to the output. Okay, so we've gone ahead and defined our add function. Now we need to call it. So up inside of ready, I'm going to write down underscore add, and then I'm going to have my opening and closing parentheses. But as you can see, this is resulting in an error. The line of code is red, and down here in the output, we have an error message. The reason why is because we are trying to call a function that has two parameters, A and B, but we are not sending anything over. So whenever we declare a function with parameters, we need to add them within the parentheses. So here I'm going to add together, for example, maybe 5 and 8. So now that we have our two parameters sent over, if I press play, we should see the 13 gets printed to the output, okay? That is the sum of these two numbers. Now in the next lesson, we are going to continue on with functions, looking at returning values. So thanks for watching, and I'll see you all then. Alright, let's continue looking at functions. So, we've already looked at how we can create our own custom function called add, which takes in two parameters, A and B. Now, a good way of thinking of parameters is basically like temporary variables, okay? We are essentially declaring a variable for this function to use, okay? And once this function has finished running, those variables essentially just get deleted. Now, inside of the ready function, we are calling the add function, adding together 5 and 8. And what this is doing is then printing out the result. But what if, for example, we wanted to have that result? What if we wanted to be able to then use it? Well, that is where returning comes into play. Returning essentially is the final little topping of a function, okay? A good way of thinking of functions is like a factory. You have inputs, you then have the process, and then you have the output, okay? For example, inside of the add factory here, we have A and B as the inputs being shipped in. Then we have the calculation here being actually, utilizing those parameters and creating something new. And then what we can do is return, which is then outputting the result. So what I'm going to do is replace the print line of code here instead with the word return, a space, and then sum. So what we are doing here is returning the sum, but what does that mean? Well, what we can then do up inside of the ready function is print out this function here. Now, this looks a bit strange. I'm printing out a function, but since we are returning a value here, basically you can look at this as being the number that gets returned. So if I press play, we should have the number 13 in the output, okay? A better way of looking at this might be like this, all right? So I'm going to create a variable here called result, and this is going to be equal to the add function, which is going to send over the number, let's just say 33 and 91. Then what we can do is print out that result. So we can go like so. Now, basically what we are doing here is the add function is going to add 33 and 91 together. It is then going to return that number. So returning it basically means that it is then going to, in its essence, be equal to that number. And we are then assigning it to the result variable and then printing it out. So if I press play, we should see that 124 gets printed. So that is basically the basics of returning values. Again, you can think of a function like a factory. You have inputs such as the parameters here. You then have the process, which is essentially the code that we run inside of the function. And then finally, we have the output, which is us returning whatever, I guess you could say, we created within that function. Now, not all functions have returning values, and not all functions have parameters. You can see the ready function here has no inputs or no parameters, and it doesn't have anything it returns. It's essentially just us saying we want to run this function, and we then do. Whereas with process, it has a delta parameter, but no output. And the add function that we created has both inputs and outputs. So basically, you're free to create your functions however you wish. Now, let's go over one more thing, and that is statically typing our functions. Because when we're declaring a variable, up here, for example, we'll create a variable called score. We'll go int equals 5, for example. Now, this int here is basically us statically typing our variable, aka defining the type hard-coded, okay? Again, this is not something you have to do, okay? Writing down score equals 5 works just fine, but if you have a bunch of variables, it's generally nice to know exactly what that variable type is. So statically typing it by declaring its data type is a good practice to follow. Now down here with our add function, we have A and B. Now what is A and B? If you're basically sending this code over to a team member to work on, they might look at A and B and go, is that a number? Is that a boolean? Is that a string? You know, it's kind of hard to see this way. So what we can do is statically type our parameters by basically having the parameter name, then add a colon, and then its type. So we'll go float. Because we might want to be able to add together decimal numbers. And then B, that might also then be a float. Okay, so essentially what we are doing here is we are defining the type of value that must be sent over as A and as B. And then also some here we can define as a float as well. And then the second thing is going to be defining the return type, okay? Because even though this function takes in floats, we might want to return a string that says, you know, we had success, or we might want to return a boolean, true or false. So also defining the return type can be valuable. Now to do that, I'm going to go to the end of the function declaration here, just before the colon. I'm going to go space. I'm then going to add in a dash and then a greater than sign, okay? So it looks like a little arrow. And then I'm going to write down float. So essentially what I'm doing here is I am saying that the add function is going to return a floating point number, a decimal number with this little arrow pointer here. Now again, this is optional, but it is best practice to follow, as later on, if you go back to an old function and you see all these different parameters with weird names, in your head you might be going, hey, I don't know if that's a number, I don't know if that's a boolean, I don't know what information is being sent over. Whereas if we add in its data type, it can become a bit more obvious. Alright, now let's have a little bit of a challenge. I want you to go ahead and create a function called has1. Now this function is going to have a parameter called score, which is going to be of type int, and it then needs to return true or false for whether or not the score is above 100. So if the score is above 100, return true. If it's below or equal to 100, return false. Okay, so have a go at that, and I'll be right back to see how you're done. Okay, so I hope you had a go at that challenge. Let's now hop over into Godot and have a look at how it can be done. So what we're going to do is we are going to go ahead and create a new function. So let's go to a new line down here. And this function is going to be called has1. Okay, so basically has won the game. We are then going to have a score that gets sent over. And this is going to be a score of type integer. Now, since this function is going to return true or false, let's go ahead and define that here. So I'm going to go dash greater than, and then write down bool, as this is the type of variable or type of data that we are going to return. Then inside the function, we are simply going to check to see if score is greater than or equal to 100. Now, what is this greater than or equal to sign? Basically, what this is checking to see if the score on the left is greater than or equals to 100. Now, if that's the case, we are going to return true, else we are going to return false, okay? And again, with greater than or equals, we also have less than or equals as well, okay? So that's just a little extra bit for the if statement there. So if our score is greater than or equals to 100, we return true, otherwise we return false. So now inside of the ready function, I'm going to create a variable called game over, and this is going to be equal to the has1 function, and we'll send over a score of, let's just say 120, and then we'll print out that game over result. Now let's press play, and we should see true, okay, we have won the game. But if I set the score to, for example, be 5, and play that, you'll see that it says false, because of course we don't have enough score to end the game. So there are many ways that functions can be used inside of Godot, and you'll definitely be using these in the future for all sorts of purposes. You'll be adding in all sorts of inputs and having all sorts of outputs for your functions as well. So thanks for watching, and I'll see you all in the next lesson. Hey everyone, in this lesson we are going to be looking at vectors. So vectors basically allow us to represent a position or direction in code. Now I'm going to hop over into Godot and begin start teaching you about what vectors are and how we have actually already used them. So here I am back inside of Godot, and what I'm going to do is actually not go into our script just yet, but instead go over into 2D mode at the top of our screen, okay? Remember, we're in our intro to scripting scene here, and I'm going to add in a new node. So I'm going to go down to sprites, and I'm going to drag in my player PNG to create a new sprite 2D node. Now, we got our player here, and we can of course move them around, and in the inspector, if we open up the transform section, we can see our position, which has an X and a Y, and that will of course change depending on where we move our player to. Now this position is actually what is known as a vector. If I hover over position, you'll see this pops up, and this basically tells us how we can access this position property inside of code. And at the top you can see it says vector 2. A vector 2 is essentially a vector with two different axes, an X and a Y. Whereas in 3D, if I hop over to one of my 3D scenes here, select an object, go to transform, hover over its position, you can see it's called a vector 3, okay, because it has X, Y, and Z. Now again, a vector can be used for many things. In terms of position, it is being used as coordinates. So the x is the number that our player is positioned horizontally, and the y is the amount of pixels that our player is positioned vertically. So this vector can then be utilized to position our player, and what we can do inside of our code is change this position vector to whatever we want, and even over time, so we can simulate the player moving in real time. So what I'm going to do is put my player about here so that if I press play, we can see they are at the top left corner of our screen. Then what I'm going to do is go into the inspector of that player node, and down at the bottom where we have the script property, I'm going to create a brand new script. So we'll create a new script here. I'm going to save this to my scripts folder that I created. And I'm going to call this one mover.gd, okay, mover.gd. So I'll click open, click create, and there we go, the script is now created. Now inside of this script, what we are going to do is essentially just move our player around. So let's start with the ready function, so func ready. And inside of here, we are going to look at how we can actually access our position. So if I hover over that player's position property again, you can see at the top of this little box, it says property, and then in white text, position, okay? So this is something we can actually type down inside of our script. So if I write down position, you can see it pops up here. Now, this little icon to the left basically denotes what this thing is. So P stands for property, aka variable. The F stands for function. So if I go position, and if I print this out, what we should see is our player's position being printed to the output here, okay? 99 on the X and 100 on the Y. Now, what if we actually then modify this variable? So what we can do is go position, and then for example, if we want to modify the X value, we can go .x equals, and then we can go, for example, 400. So what we are doing here is we are getting the position vector. We are then accessing the X value. So if you remember here in position, we have an X and a Y. .x means we are accessing the X value, and we are setting it to 400. So now if I press play, you'll see that the player is now at 400 pixels to the right. Okay, I can bump this up to maybe 900, and you'll see that they are even further over, okay, which is great. Now we can do the same thing with Y. We can go position .y equals, and then we can go maybe 500, okay, and then press play. And there we go, the player has moved around. But this is how we can modify the individual axes right here. But instead what we could do is also go ahead and modify the vector as a whole, okay? So what I'm going to do is go position and then equals vector2, okay, with a capital V, and then inside of parentheses we want to give it an X and a Y. So let's go maybe 500, 200. So what we are doing here is setting the position vector variable as a whole. So vector2, 500, 200, okay? If I press play, you can see that the exact same thing happens. We move our player over. So there's just two ways of modifying the player's position. You can modify the individual axes themselves or the vector as a whole. Now what we're going to do is I'm going to make it so that every single frame our player is actually going to be moving, okay? So how do we do that? Well, I am going to go ahead and create the process function with that delta parameter. Now remember, the process function does not get called once at the start of the game, but rather every single frame, okay? So inside of here, what we can do is basically change our player's position by a tiny little amount every single frame to move them. So here I'm going to go position.x plus equals 1. Okay, so what this means is that every single frame we are moving to the right at 1 pixel. So if I save that, then press play, you'll see that the player is now moving, okay? Every single frame, they're moving 1 pixel to the right, okay? Their position is being updated. We can also then, for example, plug this in as a variable. So I might have a variable here called speed, and this could be of type float equals, let's just say 10. And then instead of plus equaling 1, we can then go plus equals speed. So now we are increasing by a variable here. I can press play, and they're moving across the screen. But there is one issue here, and that is we don't want our speed to be in terms of pixels per frame, but rather pixels per second. Because remember, People are going to have different frame rates on their computer, okay? If we are changing our player's position based on frame, then what that means is if one player is playing on maybe 20 FPS, they're going to move slower than someone who's playing a game at 100 frames per second. And that is an issue. We don't want different players to have different player speeds based on their computer's frame rate. We want the speed to be consistent, no matter if you're at 1 FPS, 10 FPS, 60, 100, 1000. It should all be the same speed. So what we are going to do here is utilize this delta parameter. Now, I mentioned before, but basically delta is the time between frames. So if you have a faster frame rate, this number is going to be smaller. If you have a slower frame rate, that means frames are going to be happening a lot less frequently, thus delta is going to be a larger number. So what we can then do is multiply speed by delta. And if I save this and then press play, what you'll notice is we are no longer moving at 10 pixels per frame, but rather 10 pixels per second. And in that case, we probably then need to bump up our speed. So I'm going to change the speed here to be 100. Okay. And now we are moving 100 pixels per second. Okay. So if our frame rate was very, very slow, we would still be moving at the exact same speed as you see on screen here. We can also then move not based on axes, but rather based on modifying the vector. So I'm going to create a variable here and call this one direction. And I'm going to make this equal to vector 2. And we'll just go 1 on the x and 1 on the y, okay? Then what I'm going to do is go position plus equals direction times delta times speed. So what we are using a vector here for is a direction, okay? We are defining basically an arrow. So think of a point on a graph at 0, 0, and then another point at 1, 1, okay? This would be to the right and down. So the arrow is sort of pointing down and then 45 degrees to the right, okay? To the bottom right corner. And what we are doing is we are increasing our position by that direction, multiplied by delta to convert that to a per second time frame, and then by speed to basically give it the 100 pixels per second. Now, if I press play, you can see this is then moving. We can then change our direction. Maybe we want to make it move directly down. In that case, we would go 0 on the X and then 1 on the Y. Press play. We are now moving directly down. So that is just a quick look at vectors inside of Godot. Congratulations on completing the course. We just finished having an introductory look at the Godot game engine, okay? And we covered a range of different topics. We first of all looked at installing Godot, creating a new project, and then exploring the Godot editor, okay? At first glance, there seemed to be a lot of different things, buttons, panels, bits of text, input fields, but as we continued on, we started to learn more and more about what each of these things do and how they serve us in creating our games. We then jumped into learning the fundamentals of Godot as well as 2D development, such as nodes, scenes, tools, parenting, and cameras. We then looked at learning 3D, which involved 3D environments, models, materials, and lighting. And then the second half of the course was spent learning programming inside of Godot using the GDScript language. Zenva is an online learning academy with over 1 million students. We feature a wide range of courses for people who are just starting out or for those who just want to learn something new. The courses are also very versatile, allowing you to learn in really whatever way you want. You can choose to follow along with videos, read the included lesson summaries, or follow along with the instructor with the included course files. So thank you very much for following along with the course, and I wish you the best of luck with your future Godot games.